So today's main topic is concurrency, right? I will iterate it quickly. So just to tell you that I have written a program, right? A program will run, it will become a process after going to main memory, right? It will use some CPU and it will use some hard disk also, right? As a swap space. Okay. Now the thing is, this is my main memory. अगर मेरे पास 4 GB RAM है, if I have 4 GB RAM, it will start from 0, it will go till some address, right? We have discussed about how to convert hexadecimal to decimal, but that is not the point. So just to take perception, what do you think? Like, let's suppose यहाँ पे program के अंदर I have used one syntax which is inside this program I have done this. Let's suppose inside this program I have done this, and then I want to access the address of A का पहला element. Let's suppose there is some method, right? I don't know the method, but let's suppose there is a method to add to access the address where this first element of my array of my list is stored. People who are not aware and beginners, list is nothing but a memory location which is contiguous. Contiguous means कि first वाले का it will take 4 bytes in integer, second वाला it will take 4 bytes, third वाला it will take 4 bytes. So there will be no padding. Strictly ये तीनों को address assign होंगे and memory में आपके store होंगे, right? Memory में आपके store होंगे, ये मान के चलो. But just tell me कि whenever you are loading your anything in memory and I am taking the address of that block, will it give me address directly? यहाँ का address directly मुझे यहाँ पे मिल जाएगा मेरे program में या नहीं? Can I access my actual address of any array, class, instance, object, जो भी? Can I access my actual? Forget about JVM, forget about anything. I'm just talking about program written in Go, C++ or whatever. Why it is important, I'll come to that, because in concurrency it is important to know, right? There is something called virtual memory. Why? So basically, let's suppose I have 2 GB of RAM, right? And people can say that ki bhai 2 GB RAM, या फिर let's suppose 512 MB RAM, right? 512 MB RAM. So let's suppose you have 512 megabytes of RAM, right? Now people can say ki bhai, if you are creating an array more than, let's suppose, the memory available, and another program. So this is program, my code, whatever I have written, this is another program, koi bhi or program hai. It also wants to access the memory and it will check ki bhai there is not enough memory and it will crash. So basically what I am saying is ki ye to linearly or strongly dependent ho gaya na. What I am saying is if your RAM is low, then you might be able to run, let's suppose, parallelly 4 tasks. Let's suppose one browser, one media player, one music player, or one, let's suppose, any folder I have opened, right? The thing is ki, let's suppose you have 512 MB of RAM, and then there is something called virtual memory. Virtual memory again is a construct. It is not actually there. That's why it's virtual memory. Whenever some program deals with my resources, that program doesn't know ki bhai where exactly my actual address is. It will always know ki there is something, some address exists. There is some address which is present in memory, and this program doesn't know ki that is virtual memory, right? Virtual memory kya hota hai? I can make a RAM 0 to, let's suppose, 4 GB, but my actual RAM is present only 512 MB, right? How is it possible? I can literally, hallucinate ki bhai, I can literally tell a lie to my program ki bhai whatever program is running here, I can literally tell ki bhai you have enough memory, just go and run your instructions. How it happens is basically there is something called virtual memory, and virtual memory tries to map itself to the actual memory. How it maps, that we'll discuss again sometime later, but there is something called page table, there is something called page frame, right? How it happens is it has frames inside its data structure, right? So whatever memory we want to allocate, it actually will allocate inside my virtual memory, and it will check ki bhai whatever frame it wants to get. So let's suppose program 1 is using one array, one map, right? One map, one set, right? So let's suppose this is present in one function, right? And this is present in one function, and this is present in one function, right? So what I can do here is I can make pages. So there is a fixed size. Let's suppose the page size is 4 KB, 4 KB. So what it means is कि भाई I will allocate 4 KB and let's suppose function 1 is running. I will allocate 4 KB for my array. I will allocate 4 KB for my array and one page will go here. I will check if this page is there or not in my RAM. If it is not there, then I will say कि भाई okay, this page you have to load. Then I will load this page. The whole idea is कि भाई जब आपको किसी चीज की जरूरत ही नहीं है, why to load all of your program inside your RAM? Whenever you are using a program 1, if your certain part of your program is not getting executed, why to load all of your functionality? Why to give memory to each and every block of your code when your other programs, your other functions are not even running? So that is where a software construct comes, which is ki bhai, we will write a program, right? And that program is virtual memory. We will show this virtual memory, this mirror to every program ki bhai, you have enough memory, load whatever you want to do. I will manage which page to load or not, right? We have discussed in detail like what is virtual memory in operating system, but the whole idea is this ki bhai, we hallucinate ki there is more memory and in actual we have less memory, right? It is kind of dikhawa, right? So it's kind of show off that we are doing, but we don't have that actual memory. And so basically there is page table, right? There is page table. So mapping भी बताना पड़ेगा ना किसी को कि भाई this whatever page you have inside your virtual memory, where is it mapped inside your RAM, right? So that is where you have key value pair, and everything whatever we discuss apart from RAM CPU is always present in your operating system as a program, right? यहाँ पे की हो सकता है पेज, वर्चुअल पेज का एड्रेस टू योर एक्चुअल रैम का एड्रेस, रैम में जहाँ पे वो स्टोर है. सो why I am discussing this? You can ask कि भाई why you are even discussing this? There is something called context switch, and the question that always comes in everyone's mind is कि भाई why to use multi-threading, not multi-processing? So that is why I have discussed this कि भाई there is something called virtual memory, there is something called page table, right? Now what happens? We were talking about program. This was a program. That a program can have multiple threads. एक बड़ा program can have multiple छोटा छोटा program, right? So that's what we call multiple threads. So let's suppose this thread 1 is having some functions, some code lines. This thread can have some functionality. This thread can have some functionality, right? All of these threads have similar virtual memory, क्योंकि एक program को जो शीशा दिखता है, whatever mirror of one program sees, it is available to every thread. It is available to every thread. So threads don't, threads do share memory. That is there. Program don't. So program 1 will never know ki if there is any other program present or not. One program always treat itself as a king, right? So program 1 will always assume ki bhai I am the only one who is running at currently in memory, which is a virtual memory. Program 2 will always assume ki bhai I am the only one who is running inside memory. That is what virtual memory give us ki bhai program 1 can't go inside program 2 address space. Why? Because program 1 will have allocated address space which only it can use. T1, T2, T3, if they are coming from program 1, they can only use program 1 का address space. They can't use program 2 का address space. In that way तो आपका कोई गाना चल रहा है and you opened browser and आपका गाना, let's suppose आप जो song सुन रहे तो पीछे हो गया, right? It's like that कि video देख रहे हो and you opened some folder and your video, it went back in time. So because it is, altering its memory. Cool. So now the thing is key, I have 3 threads. Now the next step is I have 3 threads of one program, T1, T2, T3, right? So one construct is ki bhai these threads have 4 CPU, quad core CPU, right? Quad core CPU. Why to use threads instead of using multi-processing? See, I have 4 threads. I can run T1 here, T2 here, T3 here, T4 here, right? Why to create छोटा process out of a bada process, bada program, then to use program itself? This is a most common question that is very confusing. Why not to use process 1, process 2, process 3, right? And similar model, let's use this similar model. Why not to why not to schedule your process instead of threads? Why is that? why not to use multi-threading, or why not to use multi-processing versus multi-threading? This is the first thing. Then second thing is parallelism versus concurrency. Both of them will be answered here. Concurrency versus parallelism. Most of the people who say that we know operating system, you can just ask them these two questions and you will get to know how much they know, because this is the only fundamental thing which matters. Okay, after this, everything in OS, in Linux, whatever you think about operating system starts from here only. Why? Because see, program one or process 1, process 2, process 3 have different virtual space. So every virtual space, they will have their own page tables. Okay, so there is something called context switching. What is context switch means, I will discuss that first, then we will come back why I have told you virtual memory. So context switch is nothing but, let's suppose T1 is the thread from process 1. All of threads are from process 1. T2 is the thread from process 1. T1 says, I have the responsibility to read data from DB or to make a HTTP call to weather client to get latest weather. It will take 2 seconds. Response time or round trip time is 2 seconds. T2 will say कि भाई okay, you are getting database का response, I don't care, I am only doing some calculations. I am calculating, let's suppose I am doing binary search, right? Now this binary search is all happening in memory. You have array present here in your code. You are doing for I is equal to 0, for j is equal to 0, mid ye wo, right? You are just executing algorithm here. Whenever you are using algorithm, like wherever 0 plus 1 plus 2 minus 1 minus 2, whatever arithmetic operations are happening, that is CPU intensive task. What CPU intensive means, CPU always oscillates, it has some frequency. So CPU is 2 gigahertz, means giga लगा लेना कितना होता है, I don't know, it is 10 raised to power, I don't know, whatever, right? तो एक सेकंड में इतनी बार CPU can run instructions. So CPU will say 1 plus 2 करना है, okay, I can do millions or billions of such 1 plus 2 things in under a second. So CPU is that much fast. It will use registers and all we discussed. So this is a CPU intensive task. Thread 2 is using CPU. Thread 1 doesn't care even ki bhai CPU is there or not. It will just say ki bhai there is some service, there is some thing on network, I will just make a call, I'll wait for a 2 second. So program 1 is written such that here you make DB call, you fetch weather, and after few lines of code you do one thing, binary search, right? This program, this code block is ran by T1, this program is ran by T2. Now tell me one thing, this is your timeline, जैसे जैसे टाइम बीत रहा है. So let's suppose T1 is scheduled first, and then T1 will take 2 seconds. After 2 seconds, T2 got scheduled, right? After 2 seconds, T2 got scheduled. If it only took 1 millisecond, because it is CPU intensive task. It is an IO, input output. It is doing input output from DB, from file, from network, from what I say, from maybe reading data from USB, whatever. It is doing something which is dependent on something else, which is like reading from someone. Is it like better in this thing ki bhai schedule T1 first, wait for 2 seconds, then schedule T2? Assuming we have only one CPU, assuming my CPU cores, I have one CPU core, I have only one CPU. If there are 4 CPU, T2 to will go to another CPU, right? T2 will say okay, T1 is getting scheduled, okay, I'll go to another CPU, I'll use that CPU, right? Although T1 is not a CPU intensive task, I'm just allocating T1 first and then T2. Is this a good approach? Or T1 came just after 1 millisecond, I got to know ki bhai T1 is the IO bound task, it is requesting some resource. I will say ki okay bhai, you are running, you are in running state, go to wait state, right, till your process is not done. Meanwhile, I will do T2 fatavat, 1 millisecond ke andar T2 finished. Then I will say ki bhai okay, now you can go whatever time you want to take, right? What is a better approach here? No, T1 here. First one or second one? In first one, we are letting T1 to run, and we are saying T2 ki bhai, we know you are very fast, you will be able to run in 1 millisecond, but please wait because there is only one CPU present and T1 is blocked. T1 is blocking your resources. Will we do that, or we'll say T1 ki bhai तुझे तो 2 सेकंड लगेंगे, just go and wait, I will quickly finish T2 first and then you can use my resources? What is a better approach, first or second? Second, why? See, why second? See, the thing is we are talking about 2 threads now, right? इसलिए हमें लग रहा है कि मे बी फर्स्ट वाला भी सही है. Let's suppose I have, so in our production we have 65,000 threads. So अगर 65,000 में let's take 1k thread only, right? 1k thread only, and I am able to schedule. I have T1, T2 and T100. If I know कि भाई T100 will take 1 nanosecond, T2 will take 10 millisecond, I will say कि भाई T100 अपना काम करो, फटाफट जाओ, someone is waiting for you, right? I will not say कि भाई wait for 10 millisecond and then take only 1 nanosecond to execute. This T100 is a very lightweight process. I am saying to a lightweight process कि भाई I know you will be able to run under 1 nanosecond, but क्योंकि T2 को मैंने पहले schedule कर दिया, I have scheduled T2 first, that's why please wait. We can't do that, right? So scheduling has to be very perfect here. So multi-threading में first thing is multi-threading में scheduling has to be very perfect, right? DULING. You should know कि भाई what is a IO bound task, what is a CPU bound task. IO simply means you are doing a network call, HTTP call. We have not discussed async programming yet. We have not discussed. Just bear in mind कि भाई when T1 was waiting on my CPU, I have to load off T1 and schedule T2 कि भाई T2 तू चल जा पहले, then I will give my resources to T1. It is a blocking thing. मतलब T1 was blocking my resources. It is a blocking input output. ठीक है? We'll come to that, but DB call, maybe file read, and CPU is just like running some algorithm, right? Running some algorithm, doing some arithmetic operation like plus minus, divide, multiplication, whatever, right? ARTHEM, whatever, okay? ठीक है? तो first of all, दो तरह के टास्क होते हैं. There are 2 kind of tasks, IO task and CPU bound task, right? Now let's come back here. So the thing is कि if you have 4 CPUs, you might not see the problem कि भाई, okay, why to make threads when you can make process, right? Let's suppose you had P1, you had P2, दो process है. Instead of making T1, T2, 2 threads of P1 and T3, T4, 2 thread of P2, what you did is you said that multi-threading doesn't even exist. Let's say you will do thing like P1 and P2, right? P1 and P2, and if you will talk this like multi-threading versus multi-processing in a scenario where you have multiple processor, you might not be able to see the problem. But let's say you have only one CPU present, only one worker present which is able to handle off your load. Here what will happen is whenever I am doing P1, whenever I am running P1, will go here. It will say कि भाई I will take 100 millisecond. P2 will say कि भाई I will take only 1 millisecond. But my scheduler scheduled P1 first. ठीक है? So whenever you are talking about multi-threading, multi-processing, there are common rules. First rule is don't trust the scheduler. Scheduler can mess up. Even now also you will see on low-end PC your Ubuntu will hang, right? Ubuntu कभी-कभी hang हो जाता है because its scheduler is not using any, I've explained that, but its scheduler is not that smart as of now. तो कभी-कभी होता है scheduler mess up, right? It is not able to figure out the round trip time कि भाई कितना, which processor will take what approximate time. Second thing is don't assume. I'm not making this up. These are actual terms, okay? Whenever you are designing a scheduler, whenever you are writing multi-threaded program, don't assume sequence. Don't say कि भाई P1 will, I have written code, है ना? I've opened folder 1 first and then I've opened browser second. So folder will get opened first and browser will get opened second. It doesn't, work in that way. The sequence doesn't matter. Although right now our computers are so fast that as soon as we click on some folder, it will get automatically opened. But in, older computers, whenever you are running a video and you are clicking on a video first and then you are clicking on a folder, your folder will get opened first, then video. And so don't assume sequence in terms of threads, process, whatever. You have to process P1, P2. You have multiple threads of P1, T1, T2, T2, T3. Don't assume sequence ki bhai T1 will run first, T2 will run second, T3 will run third. So this is the second thing whenever you are writing any multi-threaded program, right? So don't trust the scheduler who will get scheduled. Don't assume the sequence ki bhai who will get scheduled first and then second, right? ठीक है. So now let's suppose P1 scheduled, it is taking 100 millisecond. Meanwhile, P2 came. Now my kernel will say, my kernel has the scheduler, right? Whenever these processes are getting into hardware, my kernel is interrupting them and saying ki which process has which state. We'll come to that. If P1 is running, P2 is waiting, or if P2 is running, P1 is waiting, kernel will allow processes to, use some state. But let's say kernel messed up, because don't trust the scheduler. So scheduler inside this task scheduler messed up. P1 got scheduled first. What will happen? Now P2 came and it will say ki bhai, someone is waiting for me, right? Someone clicked on me later on or first, I don't know. But I am the most, fastest process available. I am a folder. Someone is trying to open a folder and you are a 4K video, right? Please let me open first. So kernel will say ki bhai, okay, I messed up first because user clicked on video first. So let's schedule P2. Let's remove P1 from running state to wait state. Let's do P2 scheduling. This is what we call as switch, context switch. Context is being switched from P1 to P2, and this is where your multiprocessing hits up, the bottom top bar. So jab you do context switch in process versus context switch in thread, what are the differences? I have already told you that processes use virtual memory. They have their own page table. If a process is running on a CPU, it will have its own registers. If a process is running on our memory CPU, it will, let's suppose it has opened two files, file 1, file 2, right? And it has some CPU cache. You don't have to go in detail, but it will use some CPU cache. But in case of thread, right, instead of switching process, instead of switching process P1 to P2, I'm switching the thread T1 to T2, which are coming from the same process P1, right? So whenever you are doing context switch in thread, okay, whenever you are doing context switch in thread, it will have same memory rahega, because memory is global to process, not to thread, right? Same memory, you don't have to change any memory mapping. People might see it कि भाई क्या ही है, थोड़ा memory mapping ही तो change करना है process के case में. If you are going from P1 to P2, what you have to do? You have to change your memory address space. You have to change your page table, because you have to change your register जो भी use हुए थे. File 1 and file 2 is opened by process 1. Same file I can't give access, because file, whenever you open a file inside your code, it is a pointer. I can't give a pointer to process 2. So I have to say file का context कौन से file open थे. File descriptors are there, but pointers are there. Okay, CPU की cache में क्या store होता है, to store them. So all of this will get stored in process control block. And this context switch and storing the context of a process is a very huge task as compared to storing a context of thread. In case of thread, you just have to store stack, you just have to store program counter, because you might remember that we have discussed that threads have their own stack, and Ayush also posted one blog where he discussed about this multi-threading. You can go through that blog. It's very beginner friendly. I went through that. So stack, program counter, right, and global variables remain same. So in case of threading, it is just a software context switch. Software means you just have to store some of the things which are already available, and note that hardware thingy, right? आपको register में जाके और cache में जाके, you don't have to take out all the things, right? And there is one more thing, people who are curious, when we were discussing about this thing, virtual memory, instead of page table, you have translation look aside buffer, TLB. तो दैट इज ऑल्सो सिमिलर बट इट इज वेरी फास्ट, ठीक है। तो इन केस ऑफ प्रोसेस TLB को भी आपको फ्लश करना पड़ता है। सो इन केस ऑफ प्रोसेस इट्स अ वेरी ह्यूज कॉन्टेक्स्ट स्विच ओवरलोड ओवर हेड, ठीक है। सो दैट्स वाई multi-threading is preferred first, then only multi-processing if you have multiple CPU available. Now we talked about one CPU. If you have multiple CPU, right, multiple CPU, I will try to use threading first, क्योंकि भाई if I am using threading then I know कि भाई 4 CPU can execute P1 quickly because I am able to run threads parallelly. And even if a context which happens on a CPU core, let's suppose I have ran T1, T2, T3, T4, all of them are coming from single process. T1, T2, T3, T4. Now I know if any context which happens, let's suppose T2 thread is being context switched by T2 dash, which is coming from P2 process. I know by these threads are still running on multiple CPU cores wala setup. So that's why I always prefer, instead of flushing T1, T3, T4, T2 all and only scheduling T2 dash of P2, I will have still some threads running of P1 process. So that's why I always, we always try to schedule little, or I should say small process program which are threads, because of the things like you don't have to go too much into the hardware to flush things out, right? So okay, so this is what I will attach. Concurrency versus parallelism we already discussed, but it is similar to like if you have two CPU, right, you can run two threads or two process, right? So this is what we call parallelism. Means P1 don't know ki bhai what all process are there. He only knows about ki I'm the only one who is there, right? Because it doesn't have any context of address space, it doesn't have any context of registers of P2, anything, right? And we also discussed that registers are nothing but hardware component to store your process ka whatever it is doing with plus minus 1 plus 2, 1 and 2 will go to registers. So registers are also local to your CPU. So if R1 R2 of this CPU core is there, then R1 R2 of this process or CPU2 doesn't know even about ki bhai what all registers are there, right? So P1 doesn't have any idea. So it is what is called is parallelism, ki bhai two things are running in parallel manner, nobody knows about anyone. But if you have single CPU, or in a matter of time you can discuss about two CPU also, right? And if two threads are getting scheduled, right, if two threads are getting scheduled, if T1 takes 1 millisecond, right, and T2 takes 2 millisecond, so there is something called pseudo parallelism. What will happen is there are two configuration possible. Run T2 for 2 millisecond. After 2 millisecond, T1 will come, right? It will take 1 millisecond to run. So the total time taken is 3 millisecond, right? But let's say this T2 is taking 20 millisecond. It is waiting for 20 millisecond. So meanwhile, I will run 1 millisecond, right? 1 millisecond ka process, and this T2 is getting some data from DB, right? So 1 millisecond ka process, which is T1 thread, I will run first. And then after, let's suppose 20 millisecond, whenever I have got this data from DB, right? After this 20 ms, I will get the data from DB. And after this 20 ms, I will say, bhai, T2 got the data. So it is also finished. The execution of T2 is also finished, right? So in first execution where I will schedule, let's suppose T2 for 20 millisecond, and then T1 for 1 millisecond, total time taken here is 20 plus 1, 21 millisecond. If I schedule T2, and T2 is blocking in nature, means once T2 got scheduled, it will wait until data from DB comes, and then only it will release the CPU. In second case, T2 came and it got to know, CPU got to know कि भाई T2 is a IO bound task, it needs some data from DB. So what it will do, T1 को बोलेगा कि भाई 1 millisecond के लिए चल जाओ. After 20 millisecond, T2 will come and it will say कि okay, I got the data from DB. Here, how much time you are taking? Can you tell how much time here you are taking? T2 ran first and T2 got, T2, what T2 did is it made some DB call. Now DB is doing its activity. DB is processing something, some query, and then after 20 milliseconds, DB will give the data. Meanwhile, I have put T2 from running state to rest state or wait state. So after 20 milliseconds, I came back and I said that after 20 milliseconds, meanwhile, that 20 millisecond window, I've already finished T1 because T2 was waiting on DB. So I am taking only 20 millisecond. Why? Because I ran T1 first, and 20 millisecond plus few nanoseconds, because T2 jab aayega pehli bar, it will make a DB call quickly. DB is the one who is taking 20 millisecond. After this, let's suppose 1 nanosecond, T2 will get offload and T1 will get scheduled and T2 will get scheduled after 20 millisecond. तो 20 मिलीसेकंड ही लगेगा, प्लस माइनस थोड़ा सा डेल्टा. ठीक है. सो हियर a human will come and he will observe first setup, he will observe second setup. He will say कि यार यहाँ पे तो 20 मिलीसेकंड में दो थ्रेड चले हैं, which is one is taking 20, one is taking 1. 20 plus 1 is 21 millisecond. So he will say this is a sequential process, not a parallel process, right? Parallel setup. Here he will come, he will say कि भाई 20 millisecond plus थोड़ा सा nanosecond. He will say कि 20.1 में दो thread चल गए. This is what parallelism is. But actually you know कि भाई as soon as your CPU knows कि T2 is dependent on some IO input output from DB or network, CPU will directly in few nanosecond only, let's suppose 1 nanosecond, it will directly make T2 offload from itself and it will quickly run T1. After 20 millisecond, T2 will come. So 20 millisecond plus 1 nanosecond kind of time. So the thing is, concurrency is actually, a pseudo parallelism where we think that threads are running in parallel, but they are getting offload, onload, they are getting turned off, turned on, turned off, turned on according to the scheduler, and net on net total time will come less. Okay. So thread versus process, you can read this all. I've already explained. Just for your notes, this is there. This is your homework again for the people. How Java threads map, though we have already discussed, but how Java threads maps to OS native threads, right? You know already that we have JVM. JVM has their own software threads, and then comes our own kernel threads. How JVM knows ki by which thread to map to which thread, hai na? And if there is no thread available, how it will handle. So all those kind of things. This we have already discussed. Threads and runnable, how to create thread. If you are you want to create a thread, you can just go here and you have to implement one interface, because you have to tell compiler ki bhai, whatever program I am writing this function, I want to run this function in a thread, in a separate thread than main thread. So basically, let's suppose this is our main class, geeks class. It is ran by our main thread, right? Main thread jo bhi JVM ka hota hai, which is running our program sequence by sequence, step by step. We are telling our compiler ki bhai, please take this block, put it into thread T1, which is our thread, right? Don't attach this thread T1 to my main thread. Please make it T1, and your main thread can be treated as T2, right? So now my kernel, my whatever thread scheduler, whatever process scheduler is, will handle my main thread, whatever class I'm running, and this thread, right? We have already discussed that whenever you make a thread, right, you can access get name, current thread, and whenever you are making any thread, you just have to do one thing, which is T1.start. So let's suppose you are making a public and get what can you say, get weather, right? Get weather implements runnable. So runnable, again, if you'll go inside, runnable is, again, you can say ki bhai, it's not a marker interface though, it is a functional interface. So just a different name will come to functional interface. If you'll go to course page, you will check functional interface are there. But as of now, functional interface are nothing but kind of one interface which has one method. एक ऐसा इंटरफेस जिसके पास सिर्फ एक मेथड होता है is called functional interface, right? You can create your own functional interface, but as of now, let's discuss about this. Ki whenever you are implementing an interface, which means eventually you have to override its method, you have to plug your own definition. Now here you can do whatever you want to do. you can make HTTP call here to get weather. So in run method, you can do whatever you want to do. Here you can just call public class, or let's say public, what you can say, start thread maybe. Okay. Now here what you have to do is thread is equals to new thread, and here you have to get weather, go inside thread. It accepts runnable. We have given runnable. What it is saying is, oh sorry, I think this is the issue. Cool, some silly mistake. So what I was doing is I was treating this as a method, but it's a class actually. So fine. So yeah, so what you are doing here is you are creating a thread. So whenever your compiler will come here, it will go, it will say okay, class 1 is there, okay, but runnable method is there, okay. Then compiler will check, okay, runnable is there. I have to make sure that whenever someone calls it inside a thread, I have to make sure that this whole block go inside that thread, and ye thread jo bhi banega yahan pe t2 will run this function, which is run. So what I'm saying here is ki compiler knows ki whenever you are using functional interface, it will have always one method. That's why compiler knows ki which method to run. Now whenever compiler will run this method, thread.start will do nothing, but it will create a JVM thread and check if native thread is available and start. So if native thread is available, it will use that thread, kernel thread, and it will start whatever you want to run inside that method. And compiler knows because there is only one method. So compiler knows ki bhai, this is the only method I have to run whenever this thread will start. So that's what runnable interface here is. Okay. So then comes the point, intrinsic lock and synchronized keywords. Okay. Before that, let me code one problem. Do you know about producer consumer problem? Let's discuss about producer consumer problem. This problem is in the assignment, and it will be little bit complex to understand, and we will discuss, now these are the software things like synchronize, intrinsic locks, critical sections, race conditions. Anyways, so this is not complex to know, because the things that we have discussed, that only are complex. Here there is a consumer producer problem. What this problem says is ki, let's suppose you have two threads, two programs, two service, two workers, whatever you want to take. You can say ki bhai, I have two services. What is one is auth service, where user enter his email, username, password. Whenever that sign up service, right? Whenever that user signs up, I make a HTTP request to a user service, and this user service has some file or some DB. There it will store that new user. This is an HTTP call, right? Which is a blocking IO. Blocking IO means ki bhai, auth service will make a HTTP call. It will get response. Till the response is not coming, it will wait for that time. Let's suppose 2 milliseconds, whatever, 20 milliseconds, right? Okay. Now the thing is ki when I'm making HTTP call, this is what we call sync thing. Sync API call. Sync API call means ki I have my phone, right? I am going to send WhatsApp message, and that WhatsApp message will not get received by another person till okay, what I'm saying is, let's suppose this is my phone. I'm making up an example, phone 1, phone 2. What you are doing, you are sending one message, and you will get by tick kab laga hai, right? Tick means ki your message is delivered. How do you know? You have to get some response. Your WhatsApp app will wait till that response. Until that response comes, it will not mark your message as double ticks, which means delivered, right? Here you are waiting for that. That is what means sync API. Sync call. Sync matlab I'm requesting, I'm waiting for response. There is something called async communication, right? Async communication is done using Kafka, is done using queue, is done using some intermediator. Ye intermediator aaya mere paas. What it is saying is, okay, some user signs up. Okay, some user signed up. Cool. Just tell me the user. I will say ki bhai, this user's name is let's suppose Divanshu, right? Divanshu. It will say ki, okay, don't worry, I will give this user to the user service and he will store. Now sign up service doesn't even care कि भाई user service is taking 10 millisecond, user service is taking 50 millisecond. It doesn't even care. It will just produce an event. It will tell कि भाई ये event है, ये user है. I don't care if you store or not. ठीक है. Here a simple data structure that we can use is a queue. कि भाई sign up service ने what it did is it went to some program which is, let's suppose, any queue, right? Let's say it is a RabbitMQ. RabbitMQ is nothing but a queue, let's say, right? I pushed Divanshu here and I don't even care about ki bhai, if this Divanshu is consumed by user service and stored, how much time this user service is taking to store this user. Then I will push Rahul, right? I push Divanshu, then Rahul, then Alok. And let's suppose my user service is not even available. It is taking 100 millisecond. But to push the event, I am just taking 1 millisecond. मैंने push किया Divanshu. I don't even care if Divanshu will get stored after 100 millisecond. I pushed Rahul to after 1 millisecond. I pushed Rahul. Still Divanshu is not getting stored. Rahul is here, right? I pushed Alok here. Still Alok, Divanshu, Rahul are not getting stored. Alok is here. So what I'm saying is I'm just pushing the events. I don't even care who is consuming that event, who is getting stored in my user service. That is what async communication is. So one of the very simple way is to use queue. Queue में चीजें push करते जाओ. The person who is doing, who is producing is called producer. The person who is consuming is called consumer. In our case, it is auth service is producing. Whenever a new user is signing up, consumer is user service. Whenever new user is coming, and it is storing the user in this DB. Now let's say queue का कोई limit होगा ना. Queue will have some limit. It can't be an infinite scalable queue कि भाई 10 million users signed up, user service is not even available, so all 10 million are here. I can't afford that, right? So what happens is, let's suppose I have produced Alok, then Divanshu, then Rahul, and then Rahul again, Rajat, let's suppose. Then I came and I want to produce one more, which is, let's suppose, Taha, right? Now the queue is already full. My user service is down. No one is consuming that. I will get one error. I'll get one error ki bhai, your memory is out of space. This is one condition when your producer doesn't have enough storage to produce. Another problem is your producer is not producing anything. Right, your producer is not producing. Here consumer will consume Alok. It will say कि okay, एक element remove. Divanshu, एक element remove. Rahul, एक element remove. इसको consume, एक element remove. Now let's suppose queue is empty. Producer is not pushing anything. It will try to consume. It will say no element there. It will fail. It will try to consume. What consume does is it says get call will fail. What put producer does, it does put. If your queue is full, put call will fail. If your queue is empty, get call will fail. ठीक है. This is what producer consumer problem is. कि your producer is trying to produce something when there is not enough space, and consumer problem is your consumer is trying to consume something when no one is there, right? So yeah, so we will discuss this. You can code this on your own, or I can code this. ठीक है. In our case, we haven't discussed about microservices and all. So what we will do is, we'll make one queue which is global. ठीक है. We'll make different threads. Let's suppose m number of producer, and we'll do n number of consumer. N number of consumer, and the queue capacity is C, right? So here what we want to tackle is कि भाई queue is global to T1, queue is global to T2, queue is global to T3. First rule is don't ever assume about sequence कि will T1 push first, will T2 push first, will T3 push first. We don't know. Don't assume sequence of consumer. Will T1 dash will consume first, T2 dash will consume first, T3 dash will consume first. Nobody knows. How we will make sure that whenever T1 is trying to put, or any thread is trying to put, and T dash is trying to consume or get, we are not failing. First problem is no thread is failing due to capacity. First problem is due to queue, which is global. there should be no thread error. Second thing is कि whenever we are scheduling T1, T2, T3, what it is doing? Let's suppose pick T1 thread. What it is doing? It is checking the capacity of queue, checking capacity कि भाई कितना size है, कितने element खाली हैं. T1 I am talking about put. When I am trying to put some element into a queue, checking capacity if there is at least one space present. Yes, put. These are two operations. So whenever you are doing a sequence of operations on a resource which is shared between the threads, between process, between service, whatever, don't trust कि भाई ये atomic होगा. कैसे? What I am trying to say, we already discussed, don't ever trust on scheduling कि कोई भी कभी भी schedule हो सकता है. So your T1, we already discussed, I++ is not a single process, not a single instruction. It is like I++ includes two instructions, I plus 1, whatever I is let's suppose 10, 10 plus 1 is 11, put that to I. So these are two instructions. How two instructions these will be? These are add I and 1, then put whatever result I and 1 came to, let's suppose j, put j value into I. These are two instructions. So whenever there are multiple instructions, we call them multiple instructions, not atomic instruction. Atomic instruction means कि भाई whenever you are checking capacity and you are putting an element, let's suppose your capacity C is more than 0, means there is at least one capacity is more than 0 या फिर empty space, मतलब आपकी queue में at least एक empty space है, you can put your element. This is what T1 producer is doing. Now when it is going to put the element, T1 gets context switched. First one is check capacity, second one is put. As soon as it checked capacity, it got result, let's suppose empty space is 2, which means कि भाई at least 2 vacant spaces are there. Now when it was going to put the element inside the queue, some T2 thread came and it got scheduled. This T1 was running, it got to waiting stage. Remember, we discussed T1 का process counter, stack pointer, program counter will get scheduled to thread control block. तो यहाँ पे मैंने इसको रन किया. जब मैं ये रन कर रहा था तो मेरा प्रोग्राम काउंटर ये था कि प्रोग्राम काउंटर मीन्स नेक्स्ट इंस्ट्रक्शन which we will run. As soon as my program counter was about to execute, T2 came. What it did is, E कितना है? 2 है. बोलेगा ठीक है पुट कर दो. Let's suppose T2 ran to its full whatever execution was. T2 ran, 2 vacant space थे, now it will become 1 because T2 completed its execution. T3 came. T3 will say capacity कितनी है? 1. Okay, put call कर दो. Let's suppose T3 also completed its execution. E1 becomes 0. Now because T2 and T3 completed their execution, number of elements, number of seats which are vacant became 0. Right? Now let's see. Now T1 gets scheduled again. T1 का जो भी thread control block होगा वहां पे program counter is already shifted to check capacity. पता होगा आपको check capacity and put. Your program counter जब आप यहाँ पे चला रहे थे, you completed this and your value, your local value came as 2. Remember, you were about to put your element inside this queue. At this time, I will reschedule this thread. It will say कि भाई मैंने check किया था, because thread control block में मैंने check किया था कि मेरा empty space 2 था. I know कि my empty space is 2. Let's put it. Now error will come. क्यों? क्योंकि जब ये थ्रेड रेस्ट कर रहा था ऑलरेडी T2 एंड T3 ने वो 2 स्पेस खा लिए थे. सो दैट्स व्हाट वी कॉल एज कॉन्टेक्स्ट स्विच एंड रेस कंडीशन. ठीक है. एंड सिमिलरली यू कैन थिंक कि भाई व्हाट रेस कंडीशन कैन अकर हियर व्हेन I is accessible to all elements. I is equal to 10 and there are 1000 threads, and each thread what they are doing only one thing, which is I is equal to I plus 1. Every thread comes, they increment I plus 1, they store I का value back. There are 2 instructions. Thread 1 came, I था 10, thread told कि भाई I 10 है, I checked it incremented I is equal to 11. बट जैसे ही वो स्टोर करने जा रहा था, at the time when T1 was about to store the i's value, I is equal to 11, it got context switched. T2 came. राइट. I11 की वैल्यू अभी तक सेट नहीं हुई है क्योंकि T1 कॉन्टेक्स्ट स्विच हो गया बिफोर दिस इंस्ट्रक्शन, बिकॉज देयर आर टू इंस्ट्रक्शंस नॉट वन. I प्लस प्लस इज टू, आर टू इंस्ट्रक्शंस. T2 केम, ये बोलेगा I कितना भाई 10 है अभी भी, I प्लस 1 कर दो, 11 कर दो. नाउ T2 is able to run to its fullest, right? Let's suppose I is 11. Now I will come again T1 आएगा, बोलेगा okay, we did I is equal to 11 earlier. Yes, let's set I11. What it will do? I11. So what you did is you ran two thread T1, T2. T1 tried to, I was 10 for both of them. T1 tried to set value. It made I plus 1 11. It got context switched here. After that, T2 made I plus 1 11 because I plus 1 is calculated but not got stored to I is equal to 10. Then at the next point, what it did is I को store कर दो 11. T2 complete हो गया. Now T1 will come again. Now T1 will get scheduled again. It will say I को 11 कर दो because यहाँ पे उसने 11 calculate किया था. So after running two threads, which both of them had only one work, which is to increase the value of I by 1. I का value 10 था, होना 12 चाहिए था. I का value 10 है, हुआ 11 after running both threads. This is what we call as race condition. Race condition means एक ऐसा a resource which is shared among the threads and that resource have multiple instructions, such that if your thread switches in between of any instruction, your result will be not as you are expecting. That is what we call as कि भाई रेस कंडीशन आ गया. सो अगर मैं मेक श्योर कर दूं कि I is equals to I plus 1 हमेशा एक बार चले तो हमेशा लास्ट तक जाए. Whenever some thread comes T1, that thread should exit only once this whole block, these whole two instructions will execute, I plus 1 and set the new value of I. These both instructions will run, only then T1 will get descheduled. Only then T1 will get to waiting stage or T1 will complete its execution. That's where lock comes. Whenever we will enter to a critical section, this is what we call critical section, जहां पे भी race condition आने की probability है. A set of instruction or a block of code where you are expecting some race condition to come, that is called critical section. So critical section में enter करने से पहले lock लगाओ, acquire lock. critical section से बाहर निकल के release lock कर दो. As long as you have a lock on a room, nobody can enter the room. As soon as you have completed your work inside room, you can leave the room, unlock your room, someone will come, lock it again, complete its work, unlock the room. ठीक है, that room is a hotspot where your global shared resource is there. ठीक है. How to find critical sections? People can say one thing is global resource. It can be variable, कोई भी integer, it can be queue, it can be stack, it can be array, right? It can be db का record, ठीक है. It can be एक file की first line, कोई भी common line. When global resource is shared among multiple threads, process में share तो सिर्फ files होती हैं, but threads, services, multiple services are requesting for same db record, writing same db record, ठीक है. Then we can't assume any sequence, we can't trust scheduling or scheduler, and you know your critical section is not atomic. Atomic means you are not using any lock when entering into the critical section. Then you are fucked up, basically what I meant. Then you are done. ठीक है. You will not get the expected result as you are expecting. So very common code that you can do is, first one is producer consumer problem. Second is bank. You can code one बैंक अकाउंट, एक बैंक अकाउंट की सर्विस यू कैन कोड. This bank account has only one user, let's suppose, has bank account. He has balance 2 lakh. Let's suppose you have one method void transfer x amount you want to transfer to someone. What it will have, what it will do, it will do, so whenever you are transferring some x amount, it will reduce your balance. Whenever you are getting some what do you say, the deposit, whenever you are depositing some x amount, you will do balance plus equal to x. Now this bank account service, multiple users, I have a bank account, multiple users are transferring some amount. I am doing, let's suppose 10 users are coming and depositing some amount, right? And this is a critical section. How? Because first what I'm doing is, these are two instructions actually, balance plus x, then balance is equals to new balance, whatever I have calculated. So if one person is trying to deposit some amount and my service, let's suppose, scheduled some another person, तो जब वो स्टोर करने जा रहा है उससे पहले ही मेरा बैलेंस, similar condition, similar thing here, this thing I is equal to I plus 1, here balance is equal to balance plus x, right? So what you can do here is, let's suppose bank branch maybe, ठीक है. एंड सॉरी, ये छोटी मोटी गलती करते रहता हूँ. ओके, ठीक है. बैंक ब्रांच क्या करेगा, लेट्स सपोज मल्टीपल यूजर आर ट्राइंग टू डिपॉजिट, एक थ्रेड बनाएंगे T1. सिमिलरली रनेबल जो हमने बनाया था, यू हैव टू डू लाइक दैट ओनली, ठीक है. एंड दिस एवरीथिंग विल गो इनसाइड रनेबल. क्या नाम दे इसका, बैंक एक्टिविटी. ठीक है, इसके अंदर क्लास तो नहीं हम कर सकते, बट लेट्स डू दिस ओनली. एंड let's suppose every user comes and he always deposit 100 rupees, ठीक है. Oh, don't tell me I have to make this static also. नहीं, ये नहीं कर सकते. Cool. Bank account, because BA, because this class is not static, so I have to make one. ठीक है. Okay. So bank account, I have one class of bank account या फिर bank service, whatever. And this bank account is only of mine, ठीक है. It belongs to me only. It has balance, let's suppose 2 lakh. And then what I'm trying to do is, a bank activity is there whenever someone comes, because I have to allow multiple clients, right? User client 1 should be able to transfer money, client 2 should be able to transfer money, client 3 should be able to transfer money. So to allow client 1, 2, 3, all of them at a same time, I can make multiple threads. Each thread specifies C1, C2, C3 differently, or I can make 100 of 1000 of thread, right? So T1 बनाया, ऐसे ही T2 you can make, ऐसे ही T3 you can make. Now T1 dot start, I started all of the threads. Now whenever I am starting all of the threads, don't think कि भाई my program will stop here, कि भाई T1 dot start, it will wait for the T1 thread to stop, then it will go here. No, it only does this thing. Native thread is available, map that thread to JVM and start. Go ahead, because this thread, this whole program will be ran by main thread, right? But as soon as I have created new thread, which is T1, it will say कि भाई okay, whatever program I was running through main thread. Now I have created new thread. So whatever this program T1 is handling, this T1 handling is this process program. it will say कि भाई okay T1 तू run कर, I don't care about this process. ठीक है, again T2 will run this program, T3 will run this program. So this is the similar situation that we have discussed, like T1 T2 trying to modify I. So here I is balance. So balance is global to every thread because every thread is using this balance, and every thread is using same balance. So whenever they are doing balance plus equal to 100, they are not acquiring any C1 any lock, right? So let's do one thing, thread array बना लेते हैं, 100 threads बनाते हैं. ठीक है, so we'll make 100 threads and again where is ba dot new bank activity. Okay, so then what I will do, thread created, what I will do is ti is equal to tc this thing. So I have created, let's suppose 100 clients, hypothetical situation I am using, right? क्योंकि बैंक के अंदर एक यूजर की situation we are discussing, but it may happen that if a corporate is there and multiple transactions are happening in a corporate account, right? It can happen, multiple clients are coming, thousands of clients are coming. So I have created 100 clients here. Each client will do balance plus equal to 100, right? We have created 100 clients. I don't know if it will run successfully or not because I don't know the scheduling कि भाई कौन schedule first होगा कौन बाद में होगा, right? I don't even know. So let's try to do ti dot start, and then we can print balance. I can't make it static because balance is not static. I can make it static. And this is done, and it is saying in utility class bank account. Don't worry, bank branch. Let's go here. क्या नाम था उसका? बैंक अकाउंट. ओके, सो स्टैटिक इसलिए बनाते ताकि मेरे को वो बार बार इसका इंस्टेंस ना बनाना पड़े. अगर स्टैटिक ना होगा तो आई हैव टू क्रिएट इंस्टेंस ऑफ क्लास देन access method. But when we'll make project, we'll not use static. Not good way to use. मतलब static is not good thing to use. I don't know if the calculation is right or wrong. You can check. ठीक है, मुझे नहीं पता. So I think it's not correct. But this is the thing what I was trying to tell you. And maybe we can do one more thing. I'll take 5 minutes more. ठीक है. Where is it gone? Bank account. So whenever some thread is doing this thing, let's put one thing which is thread is, let's print two things because we are running two statements, है ना? Thread is thread dot current thread dot name. What thread I am running, then will with the amount will print. Amount is space plus balance. ठीक है. So it is before updating the balance and then after updating the balance. Let's do this. Maybe कुछ बढ़िया चीज मिले हमें. I don't know. See, random threads getting scheduled, random values are getting, see 61 thread. Okay, first start करते हैं. If 50th thread got scheduled, it incremented the value of balance. It incremented the value of, where is it present? It incremented the value of balance. Then same thread should get printed here after balance, but 52 is getting scheduled. Thread 0, 81, 95. I don't know. We got the value. Final value is okay. Final value whatever we have got. I have to comment this because final value मेरे को मिलेगी नहीं ऐसे ढूंढने से. Let's print this. ठीक है, 2,69,000, let's run it again. 2,72,100, let's run it again. 2,45,100. So it will keep on changing. Why? Because we don't even know the scheduling sequence, right? So करना क्या है, यहाँ पे पहले lock लगाओ इसके अंदर जाने से, because these you have to make it atomic. You have to make sure once thread comes here, it has to go till this line. Cool. So till now, till far, we have discussed about, hardware level things, like how my threads are getting scheduled, what exactly is context switching, and when some thread context switch versus when a process context switch, what are the differences, right? And then we looked at key multi-threading and multi-processing, what exactly is the difference, right? So now we will check some software level of things, right, where we have our Java language, and there we have some constructs, some concepts that we have to look at, because whenever you are coding your multi-threaded systems, whenever you are dealing with async programming futures, you have to keep some things in mind, right, when you are coding them. So those few things I will set the context for them. So first of all, we will discuss key exactly what a critical section is. Again, we'll discuss, already we have discussed, but I will discuss according to our example, right? And then after critical section, what exactly a race condition is, right? After a race condition, we will check what mutual exclusion is. So all these concepts are not made up concepts, right? These names are literally asked in interviews. Okay, so mutual exclusion, race condition, critical section, all three topics are very important. And after that, we'll see what intrinsic or simply locks are, right? What locks are, how you can use locks in Java locks, right? And after that, we will discuss about how exactly you will use, which is completable futures. And with completable futures, we will see what executor service is, and async completable futures and all we will check. And we'll see one project, right? We'll make one project based on few concepts like notify, wait, and semaphores. These concepts like notify, wait, semaphores, these exist in every language, multi-threaded language, right? You will be able to see notify, wait, semaphores constructs in any language like C++, Java, C, right? All these languages have these concepts, and all the other things like intrinsic locks and everything is made up on top of these fundamental concepts. So after this, we'll make a mini project so that you will solidify your theory, right? We'll make a alarm clock where multiple clients, it is a multi-client project, so multiple clients will be able to set an alarm through a central service, and we will notify those clients that by your alarm is triggered and now it's time to wake up, right? So these are some of the concepts that we will be covering with examples in our concurrency further video. Okay, so first of all, let's take an example of bank account that we coded just now, right? So this is my bank account. So this bank account class has one static, or you can just say normal balance variable, right? And this bank activity class is a runnable, right? So whenever you want to run any function inside a independent thread, right, whatever thread is invoking your bank account, that is a main thread or bank account thread, let's say. And whenever you want to do some bank activity, right, some client wants to deposit 10 rupees into your account, and he wants to do some bank activity in your bank account. So that's why I've bank activity is a separate class which implements runnable interface. So runnable interface is nothing but a functional interface. We'll cover functional interface soon, but as of now, just keep in mind that functional interface is nothing but an interface which only have one method, right? So as you are implementing this runnable interface, whenever you are implementing any interface, you have to override that necessary methods that interface has. So that method is run here. So run method, what it is doing is bank activity. Whenever someone is doing bank activity, he is just depositing 10 rupees into your bank account, right? And then we made one this thing which is a normal static function. It is static so that I can call it this function directly without making any object of bank account. We already went through static thing, right? So in this function, what I'm doing here is that I'm making an object of bank account because it's for me and my bank account is a single bank account, right? Because my balance is associated with my bank account, it's not static field. So whatever bank account is, it has its unique balance, right? So whatever balance 200 rupees initially is, that balance is associated with this be a bank account object, right? Then I have created 1 2 3 4 5 1 lakh, or you can say 10 raised to power 5 clients. So 10 raised to power 5 clients are willing to transfer 10 rupees, right? So what I am doing right now here is that I am first making up the threads. I am not starting any thread. I am just telling my compiler that make 1 lakh threads, and with each 1 lakh thread I want to pass bank activity function, right, which is a runnable. So whenever this thread will start, it will do nothing but it will run whatever is present inside this run method. So that is what runnable is. So it will just tell ki bhai whatever is inside my run method, just run it whenever thread starts, right? So first I am making up 1 lakh threads. I am storing them all in thread array, right? So this thread array is holding 1 lakh threads. After that what I will do is I will start all the threads. So what is happening backstage here is that I have one bank account, right? I have one bank account in memory. Why in memory? Because I have created one object of bank account using basically ba is equals to new bank account. I have done this, right? So what I have done is I have created new bank account. Now this bank account is holding some methods, some class, and static class it doesn't even care, right? And this bank account has one balance inside it. So what I am doing here is now first I am creating bank account inside my memory. So bank account will be here present somewhere, and this bank account has some variable balance. Now I have created 1 lakh threads, T1, T2, and so on, T 10 raised to power 5. So all these threads, what I am trying to do is all these threads are running up a function which are doing nothing but which are incrementing balance plus 10 rupees. So what exactly I am doing here is I am just accessing one common shared variable. This shared variable balance is shared across the threads, and each thread is doing balance plus equals to 10 rupees. So whatever thread is running, it is doing balance, it is fetching balance, it is adding up the 10 rupees. Then whatever b dash came, it is storing that new value into balance. So this is the instruction that we are running in each thread. So then what I am doing here is I have started all the threads. So once I call start, every JVM thread will start and try to get the native thread of my kernel. As soon as kernel will offer a thread to my JVM, my thread will start its execution, right? After that, 1 lakh clients, I will try to join them all. What exactly is join is that let's suppose 999,000 something threads already finished their work and only one thread is pending. So this line will make sure that go through each thread and check if that thread is completed or not. So first, for an example, I started 10 threads, right? So after starting all the thread, let's say one thread is still waiting. So that for that one thread, I want to wait because I want to make sure that all the threads has completed their execution, right? But so whenever you are using threads, you have to make sure that you are not accessing any common shared resource. Shared resource could be anything like a memory could be an array list, right? A map, a set, or even a single variable, right? If it is shared across the threads, then this is the first flaw in your design. Here we have balance which is shared across the threads. So this is our first flaw. Second is, do you have any critical section? Critical section. So critical section is nothing but running some instructions which are trying to modify your shared resource. So for an example, let's say I made a queue, right? I made a queue. So this queue is accessed by thousands of threads, right? Thousands of threads. All those threads they have two functionality. Either they can put any element inside my queue. They have one functionality put, they have one functionality get, right? So whenever I am doing any execution, any calculation on my shared resource across the threads, that is a pain. First thing. Second thing is, if I am doing, let's suppose the calculation I am doing put or get, is it a thread safe calculation or this is a critical section, right? Let me explain what critical section is now. So here what we are doing is we are doing two things here. People might say that we are only doing one thing, we are only running one instruction. So what we are doing is what we are accessing the shared variable balance, then we are adding value 10 inside our balance, then we are setting up the new value of balance whatever came, and we are updating our balance, right? These are two instructions actually. If you will think carefully, what you are doing, you are first doing balance plus 10, some temporary buffer will or some temporary variable will store it, and then we were doing balance is equals to b1. So first instruction you are doing balance plus 10, and then you are setting that value to balance, right? And in low level assembly, if you will try to think about it, is that you are adding balance, right, and 10 rupees, right? And first before this you are loading balance into a temporary register r1, let's say, then you are using r1 and 10 you are adding, and you are loading it into r2, let's say, right? I just took an example. The assembly instructions could be different depending on the architecture, if it is RISC or not, but that is not the point. The point here is that this is not a single instruction, these are true instructions. So whenever you are using two instructions and multiple threads, I mean whenever you are using multiple instructions and multiple threads are executing that instructions, don't assume that a thread, if it starts that instruction execution, it will complete execution. Don't assume that. Why I am trying to say that is, let's say you have three threads, T1, T2, T3. We have already discussed that whenever you are coding in multi-threaded environment, do not trust thread scheduling, do not trust your kernel for context switching, right? For your OS for context switching. Why I am telling you that is because, see, let's suppose your initial balance which is shared across this thread is 10 rupees. T1 loaded your balance first, it saw that your balance is 10 rupees. Now it will run its first instruction, which will be balance plus 10 rupees. So it added up 10 rupees. Then when it was about to set your updated value, which is 20, 10 plus 10, 20, when it was about to set your new balance, when it was about to set your balance, right? When it was about to set your balance, context switch happened before that. T2 came. Now, bear in mind, keep in mind that your balance is added in T1 context, but it is not yet set to the balance field, which means your balance is still 10, because the second instruction, the instruction which is hidden inside this instruction, which is setting up your balance after adding that, is not being run till now. So what you will do is, now here T2 will see कि भाई balance कितना है, it will still see 10 rupees. It will say, okay, balance को 10 रुपए add करना, it will add that and assume that your T2 execution completed. Okay, then your balance will become 20. Now your T3 came, it will say कि भाई balance कितना है, balance is 20, and you will add 10 rupees. So 10 rupees after adding, your balance will become 30. Now T2 completed this execution, T3 completed its execution. Now kernel will say, okay, T1 is in wait state. T1 is in wait state. What to do? Schedule that thread again. Now we have already discussed about thread control block and process control block. So whatever the context was when T1 was running, right? Whatever T1 ran till now, right? It already ran till balance plus 10 rupees. So it will directly come here. It will say, okay, I left off the things when I was trying to update balance. Okay. What it was trying to update is 10 plus 10, 20. So it will do balance is equal to 20. What happened over the period of time? You will see that T1 ran, T2 ran, T3 ran. Balance should be 10 plus 10 plus 10 plus 10. This is the initial value, thread 1, thread 2, thread 3, right? But the thing is, the balance should be 40, but after some scheduling and context switches in between, your balance is still 20, right? So that is what should be happening here also. We will check by running our test cases. In our test case, what we have done nothing but we have just directly called our static method, and this static method will make a balance account ka instance first, so that a single balance value is there present there, right? And then thousands of lakhs of threads will come and they will try to increment that balance value, and this balance field, this balance instructions is already holding up two instructions, which means this make it as a critical section, and this critical section is not mutually exclusive. So all the threads will come here and try to do some, a calculation. So let's run the test case here. Okay, non-static. Okay, we can make it static. It will not make any difference, because even if it is static, right, the thing is it is still one, right? Okay, still one means balance, single balance variable is there, not so 1 lakh threads have not 1 lakh variables of balance. They only have one variable. So we have to make sure that one variable or one resource is shared, not multiple, right? So if there is 1-to-1 mapping, like one thread is holding one balance, then there is no problem, right? So earlier, now we are getting value 1170. If you will run it again, now the scheduling is not deterministic. Your kernel doesn't know what is the order. It just goes with the algorithm, whatever is written, and in the present situation, right? So it might vary each time whenever you will run the threading model, right? So now the scheduling will differ and context switch will happen here and there. So that's why the value might change. So it is 1190, right? So it will keep changing. So what can we do? So whenever you are entering into a critical section, right? And critical section is very normal thing, which is a variable which is shared across threads, and that variable, is a single resource, right? It is not like that कि भाई आपके पास एक 5 थ्रेड है, T1, T2, T3, T4, T5, और सबके पास अपना अपना बैलेंस है, अपना अपना वेरिएबल है बैलेंस का. Then it is not a problem, right? Then तो T1 will increase its own balance, T2 will increase its own balance and all. But here we have a single shared resource, right? So this is a critical section. So here is where we use lock, right? So what exactly a lock is? Let's say, so here is what you are doing, this instruction. So before entering into your critical section, it is a very common practice that make sure you are holding up a lock. Literally, the literal meaning of lock here is to lock something and unlock something when you leave the room, right? So what you want to do is you want to check, initially your lock will be 0, means your lock is not being held by anyone. So you will check if lock is 0. If lock is 0, you will check before entering into the critical section. If it is 0, run this method, and before running this method, you want to make sure that lock is being set. So lock is 1, right? And after you are done with your execution, you will do lock is equals to 0. So what is exactly happening here is that you are checking first lock is equal to 0, right? And then you are entering into your critical section. Now let's say you are running 2 instructions already. We have seen balance plus 10, and then setting up your balance to basically modifying your balance. Let's say after running I1, T1 again got descheduled and T2 comes into the picture. Now T2 will check if lock is equals to 0. No, because before entering the critical section, T1 already made lock is equals to 1, right? So if lock is not equal to 0, you will wait. If it is equal to 0, you will proceed, and you will make sure that lock is held. After the completion of your process or thread, you will make sure that whatever your critical section you will run, after that you will do lock is equals to 0. So this is one common method, right? And in Java, you don't use counter based lock. This is a counter based lock, right? 0 1 0 1 binary lock. But here we have a very simple method, which is a synchronized, right? Synchronized keyword. So synchronized keyword can be, applied on a method. Synchronized keyword can be applied on a static method, on a variable, on anything, right? Here what we can do is synchronized bank account dot class, right? So in Java, you can apply your synchronized or lock on any object. It should be object. It should not be primitive type. It should not be primitive type like this. It should be Java ka construct, which is object. We have already discussed. And even you can use here is this. This is also an object, right? This means ki wherever you are, its own instance, right? We are inside bank account. So bank account instance is this. What exactly it is doing is it is placing up a virtual kind of memory lock, because here your balance account or bank account is there, bank account. So you are holding up a lock onto this field, onto this memory, so which is shared. Always you have to make sure that you are holding up a lock on a shared resource. You can even hold a lock on balance. No, because balance is a primitive integer type. if it is an integer like this, you can hold up a lock on balance, right? So these are some of the methods. We will go through them, right? Don't worry. Okay, so first let's see, like when we are using synchronized. So before entering into the section, we always check ki bhai, if there is at least one thread who is already operating, who is already accessing this bank account class. If yes, then I will wait. If no, then I will run this, right? Before running this internally, now the value you will get is correct. Now 1000200, let's run it again. So the thing is, before entering into the section, using synchronized inside, internally Java is making sure that you are holding up a lock, intrinsic lock. Okay, intrinsic lock, it will make sure that you are holding up a lock. You have to give something so that you can apply lock on that thing, right? So here we are using BankAccount.class, right? So let's test with this. Let's test with this. Because every thread is accessing this bank account, right? A single instance, a single object in the memory, which we can represent using this, right? So this we can represent. So again, you will get the same value. Now the thing is, can we apply, the question here is, can we apply synchronized here? What exactly it is indicating? What exactly it is indicating? Let's wait, right? You can apply here. Why? Because this class is not static. So this class bank activity, whatever class we have implemented in each thread, it is accessed through bank account only. If you will go inside this, it is always accessed through bank account, right? So even when you are running this function and you are putting a synchronized here, this bank activity is also shared, right? So this is the one thing. Let's do this thing, integer, and let's try to do this synchronized balance. Let's try to run this. Now this is a very interesting problem here, right? Because see, without this exercise, you would not even notice that why it is happening. See, every time when you are using balance, basically you have made this balance integer as a wrapper class, which makes it as an object instance. And according to Java theory, you can hold lock on any object instance, right? Because wrapper classes are also a part of object. But the thing here is that there are some classes which are immutable, like string, like integer. This is a very interesting thing here. Why? What exactly immutable means? Okay, immutable means that the value, once it is initialized to, it can't be changed. So once I have initialized my integer balance to 200, it can't be changed. It should be reassigned. So what is happening here is that what I am doing is, I am accessing the balance which is 200. I am adding up 10 rupees, which is 210. Then I am creating a new integer balance, and then I am storing the value whatever 210 rupees is. So immutable means that once it is initialized, it will make a new value. It will make a new value and reassign that value, the value whatever you want to reassign, and will make a new integer. So what exactly I am doing here is, this in theory you will not understand. That's why I am taking an example. So earlier the balance is this field which is holding up some address, right? Some memory address. You have held lock on this field. You have added lock here, right? Then this field is 200. Now before accessing this field, one thread first came, it held your lock and it made it to 110. Now this 210, because this balance field was immutable, you can't mutate the object. You can't change value stored inside that memory. What you have to do is, you have to extract the value and store again in balance, but this balance will be reassigned. So some different memory might come, right? So your lock was being held at different location. Now it will be hold on different location. Now T2 will come and will see, is there any lock on balance? No, there is no lock on balance. Because this is a different memory. So this is the problem with immutable objects. So that's why whenever you are using synchronized, always use it with the instance or some class, right? Because classes, they don't have this kind of scenario. So just do this, right? Cool. So this was one thing. So now these are some of the examples I have, for your notes. You will get notes in the description. We have basically noted here that race condition occurs whenever a shared piece of code or block or resource is shared by multiple threads and they try to change the state in any sequence. So sequence, you can't assume that if T1 is running first, then T2, then T3. It is not guaranteed at all. Then to avoid race conditions, you have to make sure that whenever your thread is entering a synchronized method, it acquires an intrinsic lock of object, ensuring that no other thread can enter any synchronized method or block of the same object until lock is released. So whatever is written here, I've only explained. And synchronized can be applied to a method, can be applied to a code block or anything. So all the examples are here. So here we have perform synchronized task. You are accessing the lock on the class which this method is present inside, right? Then synchronized can be used with a static method too, and that too at method level. So if your method is static, which means this method will exist only once, which means no class has ownership of this method. This method will exist once in method area. We have already seen that in our JVM method area, this method will exist only once. So एक ही method अगर share होता है multiple threads में, you can use that method के ऊपर lock, right? So this is how you will do synchronized. Use any class, right? Any class dot class. So that is how you will use inside static method, which you will not use at all. Using locks inside a class. So if you are inside data processor class, right? This could be any object, like it should not be integer string which are immutable, but any object, general object you can use. Even this object you can use. Okay. So you have two locks, lock 1, lock 2. You have share data 1, share data 2, right? So let's copy on IntelliJ only this example. Okay, so let me go through what exactly is happening here. So first of all, you have two shared data. First one, you have shared integer. Second, you have shared data 2, which has value initial as initial, right? Then there is one block which is update data 1. So there is one block which updates your shared data 1. There is one block which updates your new value shared data 2. First of all, if you are using update data 1, you have to synchronize lock 1. Here you can acquire lock 1 because it is an object, not string integer. Object is, you can acquire lock on object. So whenever you are trying to multiple threads are accessing this same function, T1, T2, T3, they will make sure that your lock is held on a shared lock variable, which is this. And similarly for data 2. But the thing is, if we want to process both of them, deadlock should not occur. What exactly is deadlock? Let's discuss that. Okay. So in threads, we know that we have multiple state, right? A thread is runnable. Runnable means it's ready to run, right? It is running. Basically, when thread is being running, it is executing. Its state will be running state. And then if it is again, context switched with another thread, it will be in wait or again, and then will again come to runnable state, and so on, right? I will show you the graph. So the graph here looks like something like this. So you have new thread admitted. It will be in runnable state, right? Once it is scheduled, it will be running, right? If it completes its execution, it will be exited. Right? So the state will be terminated. But if it is context switched in between when it was running, then it will be non-runnable. And once it is notified by some other thread ki bhai now you can run, it will again go to runnable state. We'll discuss about wait and notify, but all in all, that is the crux of the thread ka state. Okay. So whenever thread is running, right, it might be waiting for some lock. Let's suppose it is waiting on a lock which should be there is a lock 1, there is lock 2. So let's suppose there are two locks. It could be on anything, it could be on any object, any class, I don't know. The thing is, I want to explain deadlock. So if lock 1 is acquired by T1, lock1 is acquired by T1. But T1 thread also wants to change some data in lock in some shared variable which is managed by lock2. So it is waiting for lock2, but lock2 is acquired by T2. It is possible. Why it's not possible? It is possible, right? If there is no order of acquiring lock, let's suppose any thread comes, it tries to acquire lock1, it tries to acquire lock2. There is no sequence, there is no deterministic path. Either T1 can, sometimes if it is getting lock1, it will acquire lock1, or if it is getting lock2 first, it will acquire lock2. The order is not present, let's say. So in that case, T1 came, it acquired lock1, and before that T2 already acquired lock2, right? Now for any thread to run, it has to access both of the locks. Both locks should be acquired. That is a condition, right? Now T2 will wait for lock1 to get finished. T1 will wait for lock2 to get released. So no one of T1 or T2 will be able to execute, and they will be infinitely waiting for lock. T1 will wait for lock2, T2 will wait for lock1 to get released. So that is when deadlock happens. If you are operating on multiple shared resources, you have to make sure the either sequence exists. Whenever you are trying to acquire lock, you always acquire lock1 first, then lock2. If this sequence is there, not a problem at all. But if sequence is not there, then there is a huge problem, right? When we will discuss about semaphore notify wait, after that you can go and philosopher dining problem lead code. If you are curious, it is not necessary to solve, but if you are curious, you can go through this problem. What this problem is that you have basically 5 philosophers, right? You have 5 philosophers, 1 2 3 4 5. So what happens is this is philosopher 1, this is philosopher 2, 3 4 5. They all have plates here. They all have plates here in which they can eat, right? And everyone has a fork here. Okay, so if I am the one, okay, present here at the table, I would need 2 forks. Only then I will be able to finish my dinner, lunch, whatever. Okay, so let's say I try to acquire this fork. I acquired this fork. Basically, I acquired a lock. So I picked up this fork, right? P2 picked this fork, P3 picked this fork, P4 picked this fork, and P5 picked this fork. Now, P1 will say, okay, I have picked my right fork, done. Now let's try to pick left fork. But left fork is already picked by P5. P5 will say, I have picked my right fork, let's try to pick this fork. It is already picked by P4. So this is a deadlock situation. Okay, so one solution is, there are multiple solutions, 3-4 solutions. One solution, very simple, always pick right fork first, then left, right? Always pick right fork first, then left. In that case, deadlock will still occur. So another possible solution could be, always pick right fork first. If left is not available, release right. That could also be there. So you have to think about this, right? So let's proceed. Here, if you want to access 2 shared resources, you have to make sure that, and your calculation is, possible only if you have access to both of them, right? So here the scenario is, I will be able to print this statement only if both locks are there for me, right? So that's why synchronized, if you are using, it will make sure that you are acquiring things in order, right? So order here matters, so you will not get deadlock. So that is a use here, right? Now we will come to wait and notify methods and semaphores, right? So go to any language, right? Go to any language. It is same in every language. You have traditional methods. First method you have wait. Then second method you have notify. Then few more methods are there like notify all, etc, etc, right? So wait and notify is there. So before explaining this, let me explain this using this example only. So this was our critical section. Right? Let's try to make a variable. Okay, so what I will try to do here is, if loc equals 0, I will try to acquire it, right? I will run my method, whatever I am running my method, and before that I will make sure loc is equals to 1, right? And let's put while loop here. So I will keep checking, right? So I will keep running my loop, and I will see till loc is not equal to 0. Keep running this, right? And as soon as I get loc equals to 0 thing, right? So in that stuff, or I can say this, this is also possible. As long as your loc is equals to 1, means someone already acquired your loc. I want to do one thing, which is wait, right? It throws some exceptions, so let's do this. Let's ignore the exception on this. Okay, so as long as, so if loc is already acquired, right? Loc is already acquired, I will go inside, I will wait. So my thread, whatever thread t1, t2, t3, whatever comes till this point and already loc is acquired, it will go to wait state, right? Now let's say whoever acquired the loc, whoever thread acquired the loc first, he will first come here. Loc is equal to 1. No, loc is not equal to 1. He'll come here. Okay, so what is happening here is, this is what we call infinitely wait solution to any, critical section. So what we are doing is, let's suppose t1 came here first. T1 will say loc is equal to 1. No, so this condition will get false, so it will directly go here. It will acquire the loc, it will run its whatever it wants to run, right? Then it will make loc is equals to 0. So it acquired the loc, it made the loc is equal to 0, then notify. Let's suppose any context which happens in between. This was our problem, right? When we were discussing about this is the critical section. Let's suppose context which happens here. When your thread T1 was about to update your balance, T1 got descheduled, T2 came. It will see loc is already acquired. Yes, already acquired. It will go here and it will wait. So T2 from running state, it will go to wait state. How is it possible? Because whenever your loc is already acquired, I am putting my current thread, whoever is trying to do something but loc is already acquired, I will try to call wait. What wait does here is that whenever some thread is running, right, wait will make it not runnable. It will not able to run this method till it is notified, right? Now let's get back to T1. Now T1 context switched again. It made loc is equal to 0. It will notify. So the thread who is already waiting, either you can do notify all, like all the threads which are waiting, right? Or notify, like wake up one thread. So what this thread will do, this will do notify thread whoever is waiting. Now T2, which was in waiting state, it will again come back to running state. Now it will go here, it will try to again loop this, right? It will continue from this thing. It will tell loc equals to 1. No, loc is equal to 0 because T2 set the loc to 0. Now it will come here, acquire loc and balance and loc 0 and notify if there is any other thread. So this could also be the one solution. Let's check if it works or not. Current thread is not the owner to make it static. So just keep in mind that whenever your thread is in runnable state and As soon as it is scheduled, it will go into running state. Once it ran successfully, it will exit it and its state will be terminated. I mean, the thread is completed its execution. Or if it is context switched in between, then a wait call will come from someone. From someone, wait call will come, and then it has to go to the wait state. And then when it is in wait state, it has to wait on something, right? On something it has to wait, because see, someone is saying me wait, I will wake you up. Okay, someone said wait, I will wake you up. Then someone else came and he said कि भाई उठ जाओ, right? Please wake up. But it doesn't make sense. Why? Because if someone goes and say that I will wake you up once a cab is there, let's suppose a auto is there, right? So I am waiting on auto, on bike, on cab, right? So someone if will notify that your cab is here, you can go and board your cab, then it is a valid wait and notify method, because someone is asking me to wait on something and I will be notified once that thing is ready. So whenever you are waiting on something, you are waiting either on getting lock, either on getting some variable state to change, anything. So that's what you have to wait on something. So here I have made one shared lock. I have made object. Why? Because as you have already known that if we want to apply synchronized, it should not be string or integer, because that are immutable, right? So integer and string, their values will not be modified, their new values will be created, right? Because they are immutable. So that's why I am using object. Then final means once there it is initialized, no one can change. Then I am using is resource busy, which is false, which is a kind of lock, right? If it is busy means someone is accessing my critical section, which means it is acquired, lock is acquired. So this is a kind of nothing but a lock. Lock is acquired, true. Lock is not acquired, false, right? So now here what I am doing is I am first using shared lock object to synchronize, right? And now I will not wait for my critical section to be available. I will make sure that once any thread has the access to this block, I'll make sure that if resource is busy, right? If resource is busy, I'll make sure that wait, right? Don't enter. Though this synchronize will make sure that even if you'll not use wait and notify, still it will work, because I'm using synchronized. This is also a lock. But now I am doing one extra thing, which is I am using infinite wait. This is what we call as infinite, infinite wait signal solution. So if someone is already executing my critical section, I will wait. I will put that thread to wait state and it should get notified. So I am putting that thread to wait state on this shared lock. You have to put that wait state on something, right? So that's why shared lock dot wait, because if resource is busy is equal to true, means my critical section is already being accessed by someone. So so let's suppose, okay, take an example. T1 came, it came here, it accessed the lock, it came here, right? It saw that is resource busy, true hai? Nahi, earlier it is false. Then it went here, because if it is not true, it will skip this infinite wait, it will go here, right? Now what will happen? Is your resource busy? I am making it as true, right? So once this is true, now let's say context switch happens here, right? Now T2 came. Although T2 already has to go through this synchronized session. In Java, synchronized is already there, right? Because you can't put wait and notify outside of synchronized. See, if you will put run this, you will see that exception. What is the exception? Notify all and native method, illegal monitor state exception. So basically in Java it is not possible, but in other languages it is possible, because there is nothing called synchronized. You can use wait and notify all. So let's suppose synchronized is not there, because I have to explain you. It's not that in Java it is not possible, so I don't explain you. So what will happen? T1 will come, it will see, is resource busy, true? No, false. Okay, go ahead. It will say, go ahead, skip this, skip infinite wait, Is resource busy? True. Let's suppose as soon as it was about to run this, context switch happened. T2 will come. T2 will see, is resource busy? True. Yes, because T1 made it already true. And these are things already shared across threads, right? If it is true, it will go here. What it will do? Wait. Now T2 thread came here. It will go from runnable state to wait state, right? Okay, it's waiting infinitely. Now when it's in wait state, scheduler will again schedule T1. It will run this because T1 left its work here. Now it will make is resource busy false. It will notify. So whoever is waiting on this variable, see, I am waiting on a cab for a cab, so I will be notified once cab is there. So this whoever is waiting on this, T2 was waiting, so T2 will be running from this state only. All the context it will look from, thread control block and all whatever. Now it will run from here because we are in loop. It will loop. Is resource busy? True. No, it is already false by T1. Skip. Acquire lock. Is resource busy? Make balance plus 10. Make false. Notify all. If there are only two threads, there is no other thread waiting on this shared lock. So everything is released. But in Java, the thing is that you can't use notify and wait inside or without this synchronized. So the importance for synchronized is more in Java, what I'm trying to say, right? So here you can see the expected and final value, everything is same. So this is a wait and notify where you can put threads to wait if something is not available. That is my point. So wait to suspend a thread, notify to wake up a thread, and here you have to say that wait is nothing but a change of state or descheduling. Your thread will already deschedule if any thread is not running. It is not in runnable state, it will get descheduled. Okay, this is what you will get in assignment. Okay, people who are in cohort, you will get this producer consumer problem assignment, don't worry. Then before going to completable futures, we have to discuss about an alarm clock, right? Let's make an alarm clock. Okay, alarm clock, and let's make an alarm here. Okay, so inside alarm, let's say I have two fields. First one is if someone is setting up an alarm, right? I will ask for the date. Ki bhai, what is the date you are setting this alarm for, right? Date time. And the second field I will ask is string. Ki bhai, what is the reminder that you want me to remind about, right? So this is a reminder. So let's generate getters and setters for both of them. Cool. Okay, now what is the requirement? So my requirement is multiple clients should be able to set alarm for a particular time, and I am the alarm clock service. So I have a list of alarms which are already set, and I will trigger the alarm. So if I have a list, right, let's suppose this list can hold 5 alarms, which means I can hold 5 alarms. 5 clients can set their alarms. If 6th client will come, I will say, bhai, I have the capacity so to set 5 alarms at a time. I can't accept the 6th alarm, right? So that's what, if first client, second, third, fourth, fifth, I will use a list, and this list has to be monitored every second, because if you have set alarm in your clock will monitor every second ki bhai, is your time elapsed already or not. If it is elapsed, then I will remind you about that alarm, right? I will trigger your alarm. As simple as that, right? I will make an event loop here. Event loop is nothing but which will keep looping every second through your list. It will check if any alarm is present in your list and is about to get triggered. Trigger it, remove that from your list, right? If 5th alarm is about to trigger first, trigger it, remove it. So Now only 4 alarms are there in your list. One more client can come and set this alarm, right? So we'll make an event loop. Now here, before coding this problem, I want to make sure that you notice that shared resource we have is list of alarms, right? List of alarms. And second, you can notice is capacity. Capacity is fixed to 5 alarms, right? And clients are nothing but multiple threads. So what is happening? Let me tell you what is happening. I have an alarm clock which has a list present, and multiple clients are coming and setting up the alarm. Right? And then I am looping through this list every second, and I am checking if any alarm is about to get triggered. If it is about to get triggered, I will trigger that alarm. So this is a very simple problem. I just came up with the problem because it's the most intuitive way to explain this. Here only one thing is more, which is that your queue has some capacity, right? Let's suppose its capacity is 4, although it is 5, but let's say here it is 4. 1, 2, 3, 4, right? So whenever you are dealing with a shared resource with some upper bound on something, here it is capacity, upper bound on capacity. So what will happen? So once client 1 came, client 2 came, client 3 came, client 4 came, I accepted all the clients and I have pushed their alarms into my shared resource. These clients are nothing but different threads. Multiple clients, multi-client service. I am using multi-threaded system to make it multi-client, right? Now here the problem is, if C5 will come, I will get a exception that list is out of bounds, list capacity is full, this exception. Now C5 will to say ki, bhai, what is this, right? Why I am not able to set an alarm? So that is where we will use semaphore. Semaphore, very common or very important topic in operating system, in multi-threaded system. It has always two methods: wait, signal. Again, wait and notify that we have discussed. Semaphore is made on top of that thing, right? Semaphore also, we have two types of semaphores. We have two type, right? First semaphore we have binary or counting, counter भी बोलते हैं इसको, counting. Second we have multi-valued. What is binary? Whatever we have discussed, lock, right? Lock is nothing but a binary semaphore. Lock के पास दो values हो सकती है, 0 if it is not acquired, 1 if it is acquired, right? And let me explain it again. Binary lock, what exactly we are doing under the hood? When someone comes, acquiring a lock means 0 में 1 add करना, 0 plus 1 is equals to 1, right? Releasing a lock means 1 minus करना, 0, correct? Okay, now let's shift things upside down. ठीक है, 1 means lock is not acquired, 0 means lock is acquired. Why can't we do that? We can do that, right? We can do that. Who told you that only lock 1 is equals to acquired and lock 0 is released? Let's suppose lock 0 means acquired, lock 1 means nahi hai acquired. How I can make that? Whenever I come here, lock 0 means acquire. Again, I am telling you, acquire. 1 means not acquired. Can we interpret this? Lock is equal to 0 means no lock available, means already acquired. Lock is equal to 1 means 1 lock is available, means you can acquire. How to make it happen? Whenever any thread comes here, how he will check if lock is acquired? He can do one thing: lock minus 1. If it is negative, which means wait forever, lock, otherwise proceed. ठीक है, otherwise proceed. So what will happen? Let's suppose lock value is 0. 0 means no lock is available here in this case, because we have shifted things upside down, right? Thread will come, it will say lock minus 1 कितना है, negative है, which means wait. because lock is not available, lock 0. Or in another case, if lock is equal to 1, it will say lock -1 negative है, नहीं है. Okay, proceed. After proceeding, it will say कि भाई I am done, notify, right? So basically what is happening, T1 is coming, T2 is coming. T1 will say lock -1 क्या नेगेटिव है. अगर lock -1 नेगेटिव है, which means lock -1 नेगेटिव कब होगा, if lock is already 0 means lock is not available, then wait. ठीक है, लेट्स. और if lock -1 नेगेटिव नहीं है, proceed, and after you complete your execution, notify. This is what binary semaphore if you apply lock in this sense कि lock 0 means no lock available, lock 1 means 1 lock available, right? Now this exactly is the semaphore. What exactly is semaphore? Semaphore, whenever semaphore is, here in our case our queue value has 4 capacity, so semaphore is equal to 4, right? Semaphore 4 means 4 places in my queue are available. Let's say 4 places in my queue are available. So whenever some thread will come, right, it will call internally it will call semaphore dot wait. Now this wait code do nothing, but it does this. Semaphore value 4 -1, if it is negative, wait. No, 4 -1 is 3, not negative, means कि भाई 4 places available है, ठीक है, उसको अब 3 कर दो, which is not negative, proceed. ठीक है. So first client will be done using my semaphore. First client C1 is done. Now second C2 comes. Let's suppose every alarm is being pushed to queue and no alarm is triggered yet. C2 come, semaphore value is already 3. What it will do? It will again call semaphore wait. ठीक है. What it will do? 3 -1 नेगेटिव है, नहीं है, which means semaphore 3 से 2 कर दो and your queue has 2 clients, client 1, client 2. Now again client 3 will come, client 4 will come. When client 4 is coming, semaphore value हमें already कितना होगा, 1, right? Semaphore value 1. I will call wait, 1 -1 नेगेटिव, नहीं, तो 4th client भी गया. Now 5th client comes, semaphore value is 0. 0 -1 नेगेटिव, yes नेगेटिव, so वेट करो, इन्फाइनाइटली वेट करो जब तक तुम्हारा सेमाफोर पॉजिटिव नहीं हो जाता. नाउ यू हैव 4 clients C2, C3, C4, all are present in 4th queue. Here. Everyone came and everyone accessed one semaphore, and that semaphore was how many places are present. So earlier it was 4, then 3, then 2, then 1, then 0, or 4 clients are there. C5 came, it saw, it called semaphore dot wait. Semaphore wait internally does nothing but 0 -1 is नेगेटिव है तो वेट करो, प्रोसीड नहीं करेंगे. नाउ C1 came, इवेंट लूप चल रहा है, C1 is triggered. Now C1 once completed its execution, what it will do? Semaphore dot signal. It will execute semaphore dot signal. सिग्नल इंटरनली डू नथिंग बट जो भी सेमाफोर की वैल्यू है +1, 0 +1. सो योर सेमाफोर बिकेम 1 and it will signal all the waiting clients. C5 was waiting because semaphore was negative. It will awake, it will do 1 -1 नेगेटिव है, नहीं है, proceed. Now C4 is out, C5 is in. If you have not understood multiple semaphore concept, please go behind the video and watch again. It's a very simple concept. Semaphore has 2 calls, one is wait, one is signal, right? People call it put and get also, people call it V and P also. Geeks for geeks, it is VP, I think, PV something. But the thing is that semaphore 4 means you have 4 counter to make it to 0. Semaphore has 2 calls, wait, signal. Whenever you call wait, it will decrease semaphore value by 1. Then check if it is negative. If it is negative, wait forever. If it is positive, proceed. If it is waiting forever, any client who is completed its execution will do semaphore dot signal. it will do semaphore +1, and it will notify everyone who is waiting on that semaphore. It is similar to notify and wait. It's just that here we are using multiple values like 4, 5, 6, 7, 8, 9, 10. In notify and all, we only use 0 and 1. And analogy I have already told you from the locks, right? Lock ko, if you will assume that lock 0 means no lock is available, lock 1 means one lock is available, you will exactly say कि भाई lock is nothing but a binary semaphore. ठीक है? I can't make it more simple. It is up to you, right? You have to spend some time. So let's code the example, then you will understand what exactly I am talking about. So I will try to make this simple. Why? Because the main, agenda of this mini project alarm clock is to understand, right? So first we have private final. You can make it final, you can't make it final, it is up to you. List, and you have alarm, right? Alarm we have made it already. Alarms is equals to new array list. Let's make it empty list early, right? Initially. Then private final int max alarms is equal to 5. Okay, I can set 5 alarms and that's it, right? So first method, let's make it public void push alarms, push alarm. So whenever any client wants to set any alarm, he will do this. He will push an alarm, right? Before pushing that alarm, because our alarms list is shared across threads, because every thread will try to call this push alarm. घड़ी तो एक है ना, alarm clock तो एक है ना. We have one alarm clock, right? So every alarm clock will have this common method, because alarm clock तो एक ही object है. So every thread will access this common method. This common method means this list is available to all the clients. So this list is shared, right? So that's why I have to make sure that I am using synchronized. Okay, synchronize this. Then while block alarms dot size is less than equal to not less than, equals to max alarms. Okay, so if any client comes and he wants to push the alarm, whatever alarm is, he wants to push that alarm into our queue, and if our already queue or list whatever is already full, what we can do? We can't do anything. So then do nothing but wait, right? Do nothing but wait. So now in exception you can either do this. So what it does is, if your thread is not able to wait, some due to any crash or any exception, you will interrupt the thread and you will close it forcefully, right? That is there, but anyways, this is of no use because it will not happen. Now after this while loop, what you will do is, you will do if get date time, okay, is after. So whenever someone is setting up the alarm, I want to make sure that he's not setting up the alarm in past, right? So I am making sure that whoever wants to set the alarm, that alarm's date time is after my current date time, right? In future, only then I will be able to trigger the alarm, right? So what I will do is alarm.add, and I will add the alarm, and then I will do notify all, right? So what is happening here? Notify all. What is happening here? So here I am not using a wait on anything, notify at anything, right? No variable at all. We'll come to that. Why exactly is this? So before that, you have to know basically start reminding or start alarming function. Okay, so start alarming is nothing but it's a kind of event loop, right? Which will keep looping on your, what do you say, alarm ka list, right? So that because we are accessing the alarms, right? You have to make sure that it isn't synchronized. So you will do while alarms dot is empty. Okay, while alarms dot is empty means there is no alarm there. So in that case wait, right? In that case wait. Okay, again thread dot current thread dot interrupt return. Okay, so if there is no alarm, when you are trying to alarm, if there is no alarm, then what you will do, then you will keep on waiting, right? Wait is there. If the wait is over, right? If someone notified me, I will wake up, right? I will again check if alarms is empty. No, someone notified means if alarms is still empty, if it's still empty, I will go again to wait state. There is no problem at all. That's why I am not waiting up on any wake up call. I am not waiting on any uh, alarm कैपेसिटी और समथिंग कि भाई अलार्म कैपेसिटी जैसी +1 हुई या मोर देन 0 हुई, आई एम वेक्ड अप, राइट? आई एम नॉट वेटिंग ऑन दैट थिंग. आई एम जस्ट वेटिंग. If someone notifies me, I will check. If it is still empty, I will go again to wait state. So here it is completely fine to use wait and notify like this. Okay. So if I am able to get alarm, right, I will remove that alarm. I will remove the alarm. So as of now I am removing alarm. जो भी last पे है उसको remove कर दो, right? But you can do one thing कि loop through the list and check which alarm is triggered, right? Which alarm is triggered, or means which alarm time is already in the past, that alarm you have to make sure is triggered, right? But anyways, I am just making sure that whenever I am able to alarm anyone, I will alarm जो भी last पे, because I want to show you the example, right? Okay, get date time, nahi, get reminder. Okay, here you have to make sure you are entering plus. Cool. So then after I have notified, I have alarmed someone, I will notify all. So what is happening here is, see, so first of all, client 1, client 2, client 3, client 4, client 5 came. I am not using any semaphore here. I am just waiting pure wait and notify call. So when I am not able to push any other alarm, I will put that thread. So C1, C2, C3, C4, C5 pushed alarms. Now C6 came, client 6 came. I got to know that my queue is already full. I'll put that client to wait, right? At every second I will make sure that this start alarming is ticking, right? And whenever it is empty, because it is empty, I'll not be able to alarm anyone. If it is not empty, I'll make sure that I am removing the alarm, right? I am triggering the alarm and the alarm is triggered, right? So as soon as I have consumed the alarm, I'll make sure that I will notify all the threads which are sleeping. So it will notify this thread also, whichever wants to push new alarm, because I have consumed now one alarm. This alarm can be pushed further, right? And you can say that by if your queue is empty, this thread will also get woke up. This thread will also woke up. It will again see, it will again go and it will check if it is empty, it will go again to wait state, right? So this is the thing, right? Without semaphore and anything. So let's try to use that. Alarm clock is equals to new alarm clock, and then what we are doing is for int I 0 I less than 10 I plus plus. So I will set 10 alarms, right? I index करते हैं new thread. Although we have not discussed runnable, but functional interfaces in next session we are about to discuss. But here is a small glimpse that you can use runnable like this also. Instead of declaring one runnable, you can use lambda function here also. Okay. New alarm, local date time dot now dot let's say plus कब का सेट करना है, प्लस जो भी टाइम अभी हो रहा है प्लस सेकंड्स I plus 10, whatever index plus 10 we will do. Okay, I think this is fine, and here you have to make sure that it is in. seconds, no sorry, plus second, and reminder is alarm plus index. Okay, why is it giving error? Default constructor is invoked. Generate constructor. ठीक है. Okay, now we are good. So we are making up alarm of every whatever time is now, whatever index we are on, plus 10 seconds, and we are putting the reminder as alarm plus whatever index is, right? So a very normal thing. Then what we'll do is alarm clock dot push alarm and alarm. So we have 10 clients, right? Every client is making up an alarm, and after that every client is pushing that alarm into a thread, right? So after we have pushed all the alarms, what it is doing is nothing but it is pushing up the alarms here. Cool. So after that what we will do, try catch exception, whatever exception comes, don't care, while true, alarm clock dot set alarming, no get alarm, what was start alarming and thread dot sleep 1000 millisecond, means 1 second. So first of all what I will do, this loop will loop every 1 second, right? Every 1 second it will loop. It will try to go inside start alarming, right? So start alarming will do nothing but it will try to do alarms dot is empty, right? And here if you will notice one thing, we are doing differently. Why I have done this in this way is, see, we have made 10 threads. There is no use of making 10 threads though. Why? Because these 10 threads are doing nothing. But they are pushing the alarms, right? Pushing the alarms here. But T1 comes, T2 comes, T3, T4, T5, T6, T7, T8, T9, T10. After T5, T6 will come. Now T6 will come, it will check the alarm size. Alarm size is max alarms, it will go to wait. T6 will go to wait. T7 will go to wait, 8, 9 and 10. All the threads whatever we are making will go to wait, because all the threads they are trying to do first is they are setting up the alarm, right? If you will go inside, what they will do is every thread is pushing up the alarm. So while pushing, your T6, 7, 8, 9, 10 are sleeping already. They are waiting for your queue to get empty. Right? Every second your clock will tick. And you will start alarming. Now in start alarming, what you are doing nothing but you are checking if there are alarms. Yes, if there are alarms, you will skip this infinite wait and you will directly invoke the alarm. Last mein jo bhi alarm hai, remove that, and you will notify all the threads which are sleeping, right? So start alarming is nothing but a main alarm thread, main event loop. Only one thread will keep on looping on this thing, right? There is only one thread of alarm thread. There are multiple threads accessing the list to set the alarms. So now if this thread is getting no alarm in the list, it will go to wait state. Right? It will go to wait, and it will let people notify once your at least one alarm is set. So let's suppose at any state there is no alarm present in your queue, right? So every second this event loop will come, main thread will come. It will check no thread is present in the queue, no alarm is present in the queue, go to wait state. As soon as one client submitted his alarm, T1, T2, whatever, after submitting the alarm, you will see it will notify all. Your alarm thread will again start running. Right? That is how it is happening. Okay. I hopefully you understood that there are multi client setup and single event loop to alarm. So basically what is happening here is you have alarm, multiple people are setting the alarm, and one event loop who is alarming. That's why here we are able to use wait and notify so effectively because there are no multiple consumer. अगर multiple consumer होते, that is a producer consumer problem. Multiple producer, multiple consumer. Okay, alarm 9 triggered, 5, 7, 0, 4, 6, 2, 1, 8, 3, and done. Now your event loop is keep on looping and it will go to wait state. ठीक है, cool है. Okay, so I hope this you have understood. If you have not understood this example, don't worry, try to make alarm clock by yourself and ask GPT each step what is exactly is happening, right? Cool. So now here we can do one more thing inside your alarm clock only. We can make semaphore on capacity. Instead of doing wait, notify manually, which we've already discussed, we can do one thing which is use counting semaphore, right? For that we will use two semaphores. One is private semaphore which is vacant seats ही लिख लेते हैं. Earlier my whole list is vacant, so it is 5, right? So vacant seats are 5 earlier, and private semaphore, how many filled seats is equals to new semaphore and 0. Five. Okay, cool. So whenever I am pushing alarm, I have to make sure that I have some vacant seats available, right? So vacant seats dot acquire, what it is saying, exception will come. Okay, okay, acquire and release, right? Okay, cool. So vacant seats dot acquire, let's put them in here. Okay, so vacant seats dot acquire will do nothing but it will acquire whatever your lock is, right? So if your vacant seat is 5 will become 4 and still it is not negative, so you are able to vacate, right? You are able to acquire. After you have done, after you have added your alarm, right, what you will do? You will do filled seats dot release. So after, first you will do acquire, it will do vacant seats -1, right? So 5 का 4 हो जाएगा, you have pushed one alarm. After pushing one alarm, you will release filled seats. It will do filled seats +1. Correct? Now let's go here. Start alarming, right? When you are start alarming, okay, so when you are starting your alarm, you will check कि भाई, if you are starting your alarm, you want to check कि filled seats are positive, because your alarm wants to consume and your push alarm wants to produce. So your producer, whenever it is producing, it has to make sure that your vacant seat is getting acquired, because it is producing something. Vacant seat is getting acquired means it will decrease. Filled seats is getting released. That released seat will be used here, and you will check filled seats dot acquire. What acquire, or what we have already discussed semaphore dot wait, semaphore dot signal. Semaphore dot acquire is nothing but semaphore dot wait. Semaphore dot signal is nothing but semaphore dot release in Java. Semaphore dot acquire, what it will try to do, filled seat -1. If it is negative, wait forever once it is woken up by someone. If it is not negative, proceed. So if at least one thread has pushed something, filled seat was already incremented by 1, so it will be able to acquire. So after you are able to acquire and you have consumed the alarm, you have released something inside the queue, your vacant seat will get released or acquire. Released or acquire? Release, I think, because release what it will do, vacant seat जो भी थी, it will +1, right? So acquire, vacant seat dot acquire, filled seat dot release. After you have pushed, you are using vacant seat dot acquire, filled seat dot release, and after you are consuming, you are making sure filled state dot acquire means filled seat is getting reduced, right? And vacant seat is getting increased. So that's how it should be done. Okay, so now let's make it multi-producer, multi-consumer, right? Not a event loop, but a multiple kind of event loops, right? Because here will not tick everyone. We'll just try to do one thing, which is 5 clients pushed, 10 clients pushed, 10 clients will consume. Okay, where is it, my library test here? Now let's make, so here you are making up a thread who will push, right? Multiple threads are pushing. So now what will happen is 10 clients, they will set 10 alarms, right? So what they will do, alarm clock dot push alarm, right? So they will see vacant seats are, earlier vacant seats are 5, right? Acquire, it will get the log or semaphore, it will push, right? It will release filled seats, right? Very cool problem I got. Okay, I made a very silly mistake, and it's good that I made that mistake, because I will explain you now. So basically in alarm clock we are doing synchronized dot this. Sorry, let me, okay, so the problem is we are doing synchronized dot this. This is a huge problem here. Why? Because now we are multi-producer and multi-consumer, right? Multi-producer and multi-consumer, but synchronize this, what it will do, if anyone will go to wait state in that thing where we will be doing this thing, that multiple clients and only one event loop, in that thing wait and notify was working fine. You know that why, right? But here it will not work. Why? It will not work because as soon as we are inside synchronized, any thread comes and there is no vacant seat available, right? It will keep on waiting forever. But when it is waiting, it will keep on acquiring this log. So this instance is acquired, so no further interaction on this alarm clock. So that is the problem. We don't want to use synchronized here, right? And I think this was also a problem in wait notify thing, right? But in wait notify thing you always have to use synchronize. Now you might be wondering that just now we have used wait and release, plain wait and release, no semaphores. Why synchronized was working there? Why I told you to always use wait and notify inside synchronized always? Why? The thing is that if you'll go and check GPT or Google, whenever you are doing wait and notify inside synchronize, plain wait and notify, you will release the intrinsic log. So whatever intrinsic log your synchronized is holding, here intrinsic log is my class alarm clock instance itself. If it is holding that and I am using just wait and notify, plain wait and notify, So as soon as any thread goes to wait state, it will release the lock, so that any thread if comes to any thread wants to execute, he will be able to acquire the lock on this instance. But in case of semaphores, it is a huge problem, because whenever, let's suppose your vacant seats is already became 0, which means already 5 clients are present, so no more client interaction will happen with alarms. And when it is waiting, when vacant seats -1 is negative, it will wait forever, right? There it will not release any intrinsic lock. So if synchronized is present here, on the instance of this alarm clock, right, and if in any case our thread waits to acquire vacant seat, it will not release this. That's the nature of semaphore. That's why I told you in Java it is different when using notify and wait, that you always have to use in synchronized block. But here for semaphores you can use it in this way, right? So here you can see alarm 0865243719 whatever is able to, we are able to get that. And this is what we made as multi producer, which is multiple clients are producing, and multiple clients and multiple producers are producing, multiple clients are consuming, right, consumers. Let's go to earlier implementation only, that multiple clients or multiple producer or multiple clients are pushing the alarms, but every each 1 second we are making one thing, which is we are alarming everyone, right? So let's check this if it is working fine or not. Alarm 3 7 1 9 8 5 2 4 0 6. So this is our main event loop approach. So we have explored our event loop. So we have explored 2 approaches. First approach, we have explored that you have your alarm clock and multiple clients are trying to set alarms, and one event loop thread is running here and you are alarming them. Although whenever we are alarming, we are doing one thing, that from the list we are always removing the last alarm, whatever last alarm is present. Ideally you have to loop through all of them and check which alarm is actually about to trigger. Second problem we have discussed, multiple clients are producing and multiple consumer are consuming, right? This is producer consumer problem, which is present in assignment also. You can solve it using semaphore. Here semaphore why we are using is, to recap, because we have fixed capacity in our resource, and to hold on to the capacity we have to use semaphore. And semaphore internals, I've already explained you that semaphore has 2 methods, wait and signal. And in Java, wait is acquire, signal is release, right? Internally what you do is, whenever you wait, you try to do semaphore -1. If it is negative, you wait forever. If it is positive, you proceed. And whenever you are using signal, you are trying to do s+1 and you want to notify whoever is waiting on that semaphore. Key difference, you are always, for plain wait and notify calls, you always have to use them inside synchronized, and semaphores you can't use inside synchronized. But because whenever semaphore is waiting forever until it is notified, it always holds down intrinsic lock, which is provided by your class, which is acquired by synchronized. Intrinsic lock it doesn't release, but in plain wait and notify call they do release your synchronized lock. That's why plain notify and wait call always works inside your synchronized block. So that was the thing. Now then we have discussed that this multiple client server approach, multiple client and event loop, we have used wait and notify. We have used wait and notify with the event loop, and inside that wait and notify you have not used any this thing. You have not waiting on anything. You have not waiting on, you are not notifying on something, right?
Why we are waiting? Like we have took 2 examples, right? First example we took is of bank account. I have taken these 2 examples intentionally. Why? Because in bank account we were using bank activity, which is a runnable, for our threads, right? So whatever thread was coming, we were using bank activity as a runnable, right? So these are the threads, thread, they are using bank activity. Now bank activity object is present inside bank account, because bank activity is nothing but a runnable, a runnable class. So bank account is here, some bank account exists here. So every thread is using bank account instance, and they are using a runnable inside bank account. Each thread has their own runnable. Again, I am repeating, each thread has their own runnable, which is bank activity. Bank activity, bank activity, bank activity. If you go to the code, you will see that we have bank account, we have bank activity, and inside bank branch, we are declaring one object of bank account, and that object is passed overall to every thread, right? So every thread is using that bank account and initializing their own runnable, and then that thread is being started. Now here, the difference in this approach and our alarm clock approach is that whenever we coded our alarm clock, right, we have used normal this wait, normally wait, normally notify, normal wait, normal notify. Why? Because see, this alarm clock has simple methods: push alarm, start alarm, and those methods are associated with alarm clock. And whatever we are doing, alarm clock stuff in this method, right? And we are using a single alarm clock instance for every thread, being it a producer, be it a consumer, right? Be it a client who wants to push alarm, be it a consumer who want to start alarming, right? So all these threads have common alarm clock object, and all of them are doing nothing but pushing the alarms, and all of them then after each 1 second we are alarming them. So there, in that case, whenever we are doing wait, we can wait on the this instance of alarm clock. Why? Because every thread has alarm clock, right? But in our bank account, when I made runnable inside my bank account, now this runnable, every thread has their own runnable, right? So if I will not wait on anything, what it will do? It will do this dot wait, right? By default, if you are not doing wait on variable, it will do this dot wait. Now here the problem will arise. The problem is, if you are doing this dot wait and this dot notify, now thread 1 T1 will come. He has his own runnable bank activity. He will say, okay, this dot wait karo, this dot wait. But when T2 will come, T2 is, let's suppose, completed his execution. Now he will say कि भाई notify all. जो भी this dot notify means bank activity, this runnable के ऊपर anyone who is waiting on this runnable can start their execution. But T1 is तो waiting on his own runnable. T2 is notifying his own runnable के ऊपर wait करने वाले threads. So that is a problem. So whenever you are using runnables inside a class, so the simple thumb rule is, whenever you are using runnable inside a class and that class is being shared by threads, runnable will not shared by threads. In that case, use locks, use wait, everything use outside of your runnable. So outside runnable में हमने इसलिए shared lock बनाया है. That's why we created shared lock, a lock and everything outside of runnable, so that this runnable is not dependent for lock and anything inside of its own functionality. So that's why we have to make something like this, key wait on some common thing so that you can be notified on that common thing. In our alarm clock, that common thing is our instance of alarm clock. That's why we can use plain wait and plain notify. I hope everyone is clear with this approach. Now comes the part of completable futures, right? Before going to futures, let me explain you what exactly futures are, right? So you have one thread, right? That thread is responsible of either writing a file, reading a file, or reading from a database or network, right? So that is a dependency. So this thread is responsible of writing or reading from database. Now database is a dependency which has latency or round trip time which even we are not aware of, right? It is not deterministic, so it can be either 10 millisecond, it can be either 50 millisecond, it can be either 1 second, right? We don't know. So this thread is blocked. We will come to blocking IO, but as of now this thread will keep waiting for whatever database will take time for to give the data back, right? So this thread is blocked. So our application has threads. Let's suppose our application have 10 threads to work on. T1 went to database, it is blocked. Now our application will have fewer threads to work on. That is the problem. That is the problem, right? So that's where completable futures came. Futures means ki bhai, I will call you, but I don't need anything quickly. I will need this thing in future. In future, right? So what will happen? What will happen is we have something called futures. We have something called promises. Even JavaScript people might be aware about this thing. So future promise means it's a kind of relationship. When you are in relationship, you are doing promises in futures, right? कि भाई मैं ये करूँगा future में, मैं वो करूँगा. So these are the things like कि if I am T1, right, thread, so I am submitting a promise, right? Or I am submitting a future, I will get a promise. I am submitting a future, I will get a promise, right? So submitting a future is कि भाई in future you will give me the result, right? I don't know the time, but in future you will give me the result. I'll not wait for the result. Cool. Now the thing is कि this T1 is an application thread. So there is a difference. We have already discussed, we have a difference in application threads and kernel threads. So you have application threads, your Java has application thread and your OS has kernel threads. Now when T1 will go, T1 will submit its future. It will do nothing but it will submit the future, or it will give its work to OS thread. OS thread. And in return, OS will do nothing but a event loop is there. So there has to be one program. In our case, it is event loop. Event loop is nothing but a program itself, right? So there should be an event loop, right? There should be an event loop which should be looping again and again to check if the result is there or not, right? So as soon as OS has got result from network, जो भी network से call करना था, let's suppose some machine is there on the network which is a HTTP call made by my own OS or own machine. ये मेरी machine है, this is my machine. It is making up a call to another machine, HTTP call. So this is handled by OS thread. It will handle, okay. My event loop will keep on checking कि भाई if result is there. As soon as result arrives, it will give me the result to and another thread. It might be T1, it might be T2. That application thread will handle the future ka result, right? So before going to async futures and futures, completable futures, executor service, I want to tell you that every promise has two states, right? Either your promise will execute, terminate with exception, or either way it will complete with result. There is no intermediary state of promise, because if there is an intermediary state, let's suppose, you can suppose it for a time being that there is some intermediary state where either it is not terminated, or either it is like it is not throwing any exception, or either it is not completed. In that case, your program will get stuck, right? You will get the result, fine, you know the result. You will get the exception, you know to catch the exception and log the exception and tell the user that exception occurred, not able to get result, and so on, right? So these two states has to be there for promise. So whenever I am submitting a promise, I will get a submitting a future, very confusing. I'll get a promise on which I can later on query. What queries are possible? Few of the famous ones are कि promise dot complete हुआ या नहीं, promise dot chain करना. Let's suppose I want to call 3 HTTP clients, right? So T1 wants to call weather client to get the weather. T2 wants to call, let's suppose, wallet client to get the wallet. T3 wants to call location client to get the location. So all these HTTP calls can be made in async manner. So I will say T1 को भी वो बना दो future I will say T1 future submit कर दो, T2 भी, T3 भी, then all the promise P1, P2, P3 I can chain कि if I get P2 or P3, if I get location, I want to get weather, right? तो ऐसी chaining भी possible है. Let's see that. Okay. So before going to anything, completable futures have few terminologies. First terminology is callback. So these are the functions which are called once your operating system is done with the completion of the process that it was asked to. Callback is nothing but a function. You tell OS, right, कि भाई whenever you are ready, just call this function. Actually, OS does nothing. Okay, OS don't know कि which callback to call. Your JVM knows and your event loop knows as soon as your operating system is ready, as soon as your native thread is ready with the result, your OS will tell you that कि भाई result is ready with some signal. Now your JVM or event loop will tell or will call back your callback whatever you have submitted. Okay, so writing async code involves multiple constructs like callback, futures, etc. Async programming is non-blocking style of programming that is handled by OS level using callbacks. ठीक है, async means क्या होता है? Let me tell you that before. So I wrote some instructions. Okay, let's suppose here I want to get weather. Right, and here I want to filter an array. Now this weather condition, this code is dependent on something else, something else, right? Some other client, which is weather client or any HTTP call to any DB. I don't know. It is not depend on my application ka properties. My application property is this. I have an array and I want to do some filtering on top of my array, right? That is my application ka calculation. Cool. So the thing is कि I can do this even without waiting for this weather client का response. Let's suppose this is a blocking IO. Blocking IO means my whatever thread is running, main thread will wait until results come. Okay, and Java is a multi-threaded language. Either you can do what? You can submit a thread of weather. You can submit a thread of weather to get the weather. Then main thread will do this. Main thread will execute this. And at last you can do whatever thread you have created for weather. Let's suppose W1, you will join that, you will wait for the thread to complete. But the problem there is that this weather thread, whatever you have created, will be operated by T1 thread. This is the application thread and this is your main thread, whatever, right? This main thread will keep on executing your filtering and this T1 will call HTTP. Now this is a blocking thing. Blocking means until you are not getting the result, this T1 thread will get blocked. If you are not making any new thread, your main thread will get blocked while running this instruction. If you are throwing this weather to a different thread, that thread will get blocked until you get the result, right? So yeah, it will give you some improvement. If it is a good approach to make a thread for T1 weather and keep on executing your filtering, and at last when you are done with this, check if your T1 is completed or not, then proceed. It is a good approach, but the thing is here you are blocking your application threads, and our application threads are not infinite, right? They are limited. So whenever new HTTP requests also come to our server, those are handled by our application threads. So we can't say कि भाई my application had 100 threads and now 100 of them are blocked because I wanted to execute some of my application code and now they are not available. And your server will say कि okay bhai, then whatever you have blocked your thread to, now what about the HTTP requests? What about the throughput? So request per second, whatever the capability of my service was, the capability of request per second will decrease dramatically, right? Why? Because all of my threads I have blocked on something else. Either I made the threads like multiple threads and then I made them to call something, right? So that's why your application threads needs to be available most of the time, and that's why you always use completable futures to what do you do कि भाई ये application thread है T1, T2, this is your application T3, and This is your event loop and this is your OS. This is your OS. You will say कि भाई T1 hand over your work to OS thread, T2 hand over your work to OS, T3 hand over your work to OS. You will get the callback. Go handle your HTTP request. Now whatever requests are coming continuously on my service, those will be handled by T1, T2, T3, and wherever we left in our code, those futures will get ready. As soon as they will get ready, I will complete them, right? Okay, so whatever I have explained you till now is an example of futures, due to which you can be, you are able to do async programming, right? But before even exploring our methods or code, there is one more thing that you need to be aware of, right? And that thing is using blocking versus non-blocking streams, right? Now let's even dig deeper to level 1 of completable futures, so, or even futures, right? So what happens? So whenever you are submitting any thread T1 to read a file or to read anything from network, right? That could be blocking in nature depending whatever you are using, right? So let's suppose you want to read a file and you are using file input stream. We have discussed about this file input stream. Now file input stream is not a non-blocking nature. Once your stream is opened to a file, your file has to read the data in chunks, and that will go till your file is not being read to the end. So this file input stream will block your thread T1. So whatever I have explained till now, that your T1 overload can be offloaded to OS, then your OS will do its work, OS thread will do its work, and your application thread can go back to its normal execution, and your event loop will keep on looping and monitoring that if your result is there, then it will call your callback or your function to tell your thread ki bhai result is ready. That is a complete ideal example of async programming. But the thing is ki if you are using blocking stuff inside, right? If you are using blocking stuff like file input stream, byte array input stream, all these streams, right? HTTP stream, all these things are blocking in nature. So completable futures in Java, they from the caller perspective matlab from our service perspective, they appear to be as async service, but they are not async in nature. What do I meant by that is, completable futures is basically handled by a fixed thread pool. So this is your service and these are your application threads. Okay, these are your application threads. Whatever your application thread is, right? You have application thread, let's suppose T1 to T100. You have 100 application threads, let's suppose, and those application threads those application threads ka work I will offload to executor service. What is the executor service? I'll come to that. Executor service is nothing but a pool of threads, basically एक ऐसा container which have threads already present for a specific work. So what is happening here is, in case of blocking IO, wherever you will use blocking IO, executor service will take off your work of completable future. So as soon as you are submitting your task, you will get a future, right? And you can see here that whenever you are calculating anything async, if you are using completable futures with blocking IO, it is not actually async in nature. I'll come to that why. But here in this example, we'll take this example. There is a calculate async throws whatever, and you are making a future. Completable future is equal to new completable futures, and this completable future, whatever completable future or whatever thread wants to submit a future and get a promise back after a point of time, that has to use something called executor service. Executor service is nothing but a fixed thread pool. It has a fixed thread pool. So you are doing nothing but you are giving the responsibility of each you are giving the different responsibility to each of the threads. Application threads have the responsibility to get HTTP, whatever traffic is coming to my app. It has HTTP, traffic or anything, any request. My application threads have the responsibility of that. As soon as my application threads get the responsibility of executing anything like a DB request or anything, they will, what they will do, they will use an executor service which have the threads responsible for these functionalities only. So that is what, from my service perspective, it appears that my application threads are offloaded, or my threads are vacant. They are vacant and I can use them. But eventually, under the hood, your executor service, which still has your application threads, right? Not T1 to T100, but some T100 to T50. That thread pool will get used to do your work, your heavy work of the application threads, right? So it happens when you are still using blocking IO, right? And most of the companies, most of the startups use blocking IO only with CompletableFutures. It is not like it doesn't make sense. It is not like that. You can always increase your thread pool. Okay, your memory will increase. Okay, because threads take memory. Your memory of the overall application will increase. But a decent thread pool, like a few hundreds of thread pool, can give you thousands of requests per second ka throughput, right? But I am explaining you that why they have to use thread pool, why they can't use JavaScript wala stuff, right? Although in JavaScript there is only one thread, like, but what I'm saying is why they can't use JavaScript wala ki bhai we have three threads, will offload the thread work to OS. OS will work under the hood. It will use buffers, it will use something to output whatever it is reading from the file or DB, and that buffer my main application thread will take later on when event loop will tell ki bhai result is ready. But that is the case for Java NIO. We'll come to that, but most of the time, 90% of the time in all the companies, they always use blocking IO under the hood, right? They will use HTTP client, which is blocking in nature, right? They will use a DB call HTTP again, which is blocking in nature. If they are reading any file, they will use file input stream, which is nothing but a blocking in nature. So all these things are blocking in nature. Blocking in nature means once they are opened, they have to, whatever thread is waiting for that result, it will wait, right? So our executor service threads will get blocked, right? So you can like ask, what if we have 50 threads here in executor service, all of 50 threads are busy and our RPS is high, means more application threads are coming to submit their futures, and our executor service threads are already busy. So that's why it already has a queue, right? It will queue your threads and your latency, whatever latency of service, because no more threads can be served, no more traffic can be served, because all the application threads can't submit their future. So your application latency will increase, right? So that's what you see in production, right? That's what you see in production, that whenever your RPS increased, your latency is getting increased, then what you will do, you will increase your instances of your application. So your application agar ek container mein pehle chal rahi thi, if your application was running in one container, you will increase horizontally, you will scale horizontally, right? So that now your workload jo ek container pe aa raha tha, now it can be distributed to two containers, right? So basically I done nothing but whatever code was running in my machine, I took one more machine of my friend, I ran the same code there, and now whoever is coming to get the result from my service, I am saying that by go there, right? So it's like that. But yeah, this is a pseudo kind of async programming, which appears to be async, but it is not actually async programming, right? There you have to use executor service. So executor service. So let's take an example. This example only will take, right? Okay. So future, it will come from java.util.concurrent class. Okay. And completable future also come from that same package. And executors dot. So you have a cache thread pool. This you have to read on internet. What is cache thread pool? What is fixed thread pool? Like from the name itself, it is clear. But if you'll go here and you will be able to see a new thread pool also, new fixed thread pool, cache thread pool, right? So yeah, so what you can do here is either you can, so in this function what we are doing is calculate async, whatever program we want to calculate. My main thread will come here, whatever thread is here it will come, it will say कि भाई I want to calculate something. इस फंक्शन के अंदर कुछ कैलकुलेट होता है, वी डोंट नो, कुछ कैलकुलेट होता है. दैट T1 थ्रेड आई विल टेल कि भाई ये लो फ्यूचर, you will get the result in future. We'll cover generics, but although we have touched on this, ki bhai whatever is inside this sparrow bracket is nothing but a kind of data type that you are passing to the interface, and that interface is using that data type. So here at the v we pass string, so whatever v, wherever v is used, it will get string. So when I will call this future get, it will return me string. So that's what generics are. Basically this is a generic template that is made by programmers of Java. They made this future in such a way that you can use future on top of string, integer, character, whatever, right? All the wrapper classes. So now here in this case, whenever T1 will come, I will give him the future class, right? I will give him the future instance ki bhai yellow future, you will get the result in future, but don't bother me now. Then inside under the hood, that thread, according to that thread, so he will say कि भाई मेरा काम हो गया, I am async completely, I am not blocked and anything. Now I can go and accept HTTP request of my application. I can operate as an application thread. But under the hood, what I am doing, I am using 500 already. Sorry, not 500. New cache thread pool. Let's take fixed thread pool. Okay, so I have already 10 threads. Actually I am using the T1, I am telling T1 कि भाई तेरा काम हो जाएगा, right? So it is like a freelance agency, right? It is like a freelance Indian agency, where what happens is there is one intermediator, he takes the work of all the clients. Let's suppose he takes the work of 10 clients, right, or 3 clients in a month. Then he has some 10 employees working under him. What he will do, he will give his work T1, T2, T3 का जो work है to his 10 employees, fixed thread pool, right? And those 10 employees will do his work, and that intermediator will tell the clients कि भाई तुम्हारा काम हो जाएगा, don't worry. Now those clients are stress free, they will not take any stress कि भाई their काम will be done in few days or hours, whatever commitment is. So that's what it is doing, right? So the point to notice here is I could explain you in very simple terms, right? You might say that कि भाई मुझे syntax बता दो and I will be able to understand, but the thing is you will not understand, right? I have to explain this, otherwise there is no difference in explaining like other people on YouTube did, right? Okay, so inside this calculate async, what I am doing is I am making a completable future, and then that completable future I am submitting, right? This is how you submit executor.new thread pool. It will give you an executor service, right? Executor service. You can do this. You can initialize service first, executor service. Okay, now this service you can submit. So whatever thread you want to submit, you will first initialize this service, or even you can initialize this service here, right? So whenever someone do this, whenever someone wants to calculate anything, I will submit that something, and then there is a sleep because I want to demonstrate you. And then what I will do, after 500 millisecond, I will complete his work, whoever wanted to complete his work, right? Now this is the thing, right? Okay, so now what I have done here is I have futures class where I have a service already made. Whoever wants to come here, he will submit his ask in my this function. I will give him the result, right? So result I am doing, how I am doing result is this. Okay, cool. So I am making a future first, and then I am submitting that future inside my executor service, and I have simulated the result that after 500 millisecond I will complete that future. So complete means nothing but what could I have done here is कि HTTP call करो, when I get the HTTP result,
सो completable futures dot complete and return the result, right? ये भी हो सकता है. Oh, cool. So completable futures dot complete, I will return this. So let's go here. Whatever we have made, let's do that. Futures. Okay. Futures dot calculate async. Now calculate async, throwing some exception. So when we are calculating this, we have to make sure that if any exception occurs, which will occur if there is any exception, catch them. Unable to process futures dot calculate async. Cool. And let's print whatever it is getting. Okay. ठीक. So what I am getting here is that futures dot calculate async, it is giving me a future. It is giving me a future, right? So I have printed future itself. See, java dot future, whatever I have done, not completed. The status is not completed because under the hood this service will take 500 millisecond to get complete, right? And my application thread here, t1 is already offloaded, right? Whatever executor service I have submitted my task to, it will take 500 ms. My t1 is already freed, right? So that's why after submitting that, my whatever statements are, whatever here code is written, it will run. And let's say after a point of time I want to, so future, okay, so whatever this function will return, it will return a future of string. So whatever code I have written, this thing will take 500 ms. This promise result to be get completed will take 500 ms because we have simulated the behavior of 500 ms. So whatever the code here is written, it will run. Let's suppose we want to call more of the, so t1 application thread, it submitted the whatever result it wanted to, it submitted as a and got as a future. And now t1 can continue, the thread can continue, and it can go and call any other http also. So all the things will happen after all the instruction. Let's say after a point of time I do one thing, which is future dot get, right? Here when I call get, here I will make sure that whatever future was about to complete, when that future was doing its work using some ThreadPool, I also completed few of the tasks, right? Here it could be filtering array, here it could be for loop, anything that is also completed. Now check if future is completed or not, right? Now let's check. You will see hello pool 1 thread 1. So hello, we got the result, and pool 1 में से thread 1 use हुआ है. It's not an application thread. How? Let me prove that also. Thread dot current thread dot get name, right? Main thread था हमारा t1 is our main thread. It submitted its own task to some pool, and then it executed this statement. Main thread is only executing this statement. That you have to make sure. Why? Because whenever we are printing this, we are getting main thread. Whenever we are getting the future, it is present here, and that is 2 from pool 1 thread 1, right? So that is an example of completable future as of now. Let's go ahead. Okay, we can supply a supplier or runnable to the completable future also. See, so here what you have done. So now we'll talk about syntax, right? Which is the most common thing that most of the people on YouTube talks. But anyways, so now the thing is ki here we have used one function which is returning us as a future, right? But you can do one more thing, which is you can use lambda function also, right? The function interface we have not covered, but these are lambda functions. So here what they are doing is they are doing one thing, completable future, they are making up a completable future, right? let's see. Completable future, completable future dot supply async. Let's use its static method. Completable futures dot supply async. We'll get to functional interface, but as of now you can see that supply async accepts something called supplier. So there are some functional interfaces in Java, right, which functional interface are nothing but interface, okay, which have only one method present, right? Okay, why they exist at the very first place is because in Java someone wanted to pass functions around, like uh, there is one function, there is another function, right? We can pass arguments, integer, character and everything. We can pass integer, character or string from function 1 to function 2. But what if I want to pass function 3 from f1 to f2, right? So if you want to pass function around, you have to use functional interfaces, right? Functional interfaces are nothing but functions who have method included, at only one method included inside them, right? So we'll come to that, but as of now we'll use supplier. Supplier is nothing but it accepts nothing, it accepts nothing. So if you'll go inside, it accepts nothing, right? No argument, but it will give you something. Now here I want to get string. You will say ki why you are not telling supplier here to give string. In Java, whatever you have written here, the compiler is saying कि भाई जो भी तुम return करोगे, I don't care, it should be string. Compiler of Java is intelligent enough to use string everywhere where a generic type is used. So supply async के अंदर supplier is accepting one generic type, already string will be passed. अगर यहाँ पे दो चीज़ें होती, if u and t भी होता है यहाँ पे, if there are two generics u and t, then it would I have asked कि भाई string के साथ कुछ और भी दो. In that case I would have given like this, right? Okay. So here I am returning hello. Cool. Now this is the future that you can use, and here are the other example like future of f1, f2, f3, right? And then what you can do here is cf dot complete async you can do, or you can chain also, right? Complete async I think will try to get executor, right? Supply async और complete async भी हो सकता है यहाँ पे. ओके नहीं होता, cool, ठीक है. So basically what they are trying to do here is that earlier we submitted one future, right? What we done is we called one future, right? Some function, it got me one future, right? And this is another way of defining any future. This was one way of defining future, right? Then inside that only we submitted that to executor service. Here let's do everything in this class only. Fix ThreadPool 10, this, okay? So now you can define multiple futures, right? F1, it's just for the syntax. I want to tell you the syntax. F1, F2, F3. We have three futures. What could three futures indicate? These are three HTTP calls. Let's suppose I want to get weather. So here I will type HTTP client dot get weather whatever URL, right? Here I will get location, here I will get user, whatever, right? These are the three futures. Now I can submit these three futures to service. Submit. So now most of the people might wonder that why we can't submit a future inside an executor service here like this, right? So that's why I've took this example. So see, whenever you are, so first of all you can make a completable futures like new completable future like this, and whatever you want to do, then you can do that inside a supplier of executor service like this. Service dot submit, right? Here you can pass lambda, whatever you want to do here, http call or whatever, you can do that here, right? And then not in return state, but you can do your completable future f1 dot complete, right? Whatever you want to pass here the value, right? You can pass here, right? Or f1 dot, I think reject should be the thing, fail, cancel. Okay, if you don't want to run the future, so cancel will accept boolean में interrupt if running, yes true. cancel करने के बाद इसको interrupt कर दो. This is could be the another thing. But if you are using this completable future dot supply async dot complete async, all these methods are doing already one thing, which is if you are doing supply async, the first argument it gets is कि why, what is the function you want to run, that we given it as a lambda function, right? Lambda function. But the second thing, you can give either a service, an executable service, कि भाई whenever this function or this future is getting executed, this service will be used to execute this future. This is a similar thing that we done this here. We have made a future, then we have submitted that to a service, and then inside that we have done something. To do this in another way, what we are doing is you are making up a future. What you want to do from that future, you are passing as a function, then passing a service by which service will be used. So you are doing by what future you want, what functionality you want to run, this thread is telling you, and then this executor service is being used to run that functionality. This is what it is happening here, right? If you will not pass this service, a fix fork join poll will be used. Okay, a fixed fork join poll will be used. Cool. A fixed thread fork join poll will be used, not a fixed thread pool that we are defining here, or now of 10 threads. There is a default thread pool that will be used. Now we have defined 3 futures. They will get completed using their own service, or if you will pass service in one of them, we can pass service, right? Let's suppose in one of them we are using our own executor service, in another 2 of them they are using their own default implementation, right? So now what we can do here is f1 dot complete, either we can do this, right? And complete will take value. Okay, we can't do this, we can chain them. So let me check the chaining syntax. Chaining completable futures, if we have multiple futures, you can combine them, then combine return a completable future with transformed result. So what it is doing here is that f1 dot then combine, but then combine is get completion state by function. Okay, then accept both function type, then combine uses a by function to transform the result, then accept both use a by consumer to consume the result. So let's first do one thing, which is f1 dot get exception आएगा, fine. Then f2 dot get, then f3 dot get. Let's run this. You will get hello 1, hello 2, hello 3. All the completable futures are getting completed in parallel by this executor service, right? Now another thing that you can do here is you can chain them, right? You can chain them. Let's suppose f1 and f2, what they do is hello space and it gives world, right? World. And this what it does is supply async, this accepts a supplier. Okay, another is supplier and executor. So basically I want to change the future. So basically let's suppose I want to get I want to call 2 futures. Future 1 get location, right? Future 2 get me, let's say date, and then f3 what it does is it use location plus date to give me weather, right? So this could be the one case. So f1 gives you the location, let's suppose Delhi, date is let's suppose 20th June, right? So it will use Delhi and 20th June, and it will say if now it wants to accept something which is location and date. How to accept that? So there is something called then combine. Let's see if we can use them or not, right? We'll make this f3 inside our then combine only. So f1 dot, okay, then combine, but it accepts completion stage. Okay, so first what I've done here is f1 future, I will wait for f1 to get completed, and then I will combine it with f2, right? So we'll cover functional interface, but here what I'm passing is by consumer function, right? So if you'll go here, I am doing by function which accepts one thing t, which accepts u, and which returns v, right? So what I'm doing is location I'm getting from f1, date I'm getting from f2. This is how this is an extension of lambda functions, right? Whatever lambda functions are in Python, in other like C++, JavaScript, this is an extension of them. So this is a functional interface. So this then combine, if you'll go here and you will check, then combine accepts nothing but one, it accepts future completion stage, which is already completed, because why we have used supply async. Supply async is already submitted this future to some service. Then it gets by function. So location and date I will get. Now here I am returning 40 Celsius. What I can do here is I can return here completable future dot supply async, right? Here what I can do, if location is equals to Delhi, right? If location is equal to Delhi and ऐसे ही अभी एग्जांपल ले रहे हैं, डेट इज इक्वल्स टू 20th June, anything you can do on this data, return what we want to return is weather. Okay, then combine by function tur देगा ये. Okay, so here, okay, so what I'm doing here is that I'm combining two futures. If they have combined, whatever result they are returning, I am getting that result, and then I'm using that result to return another future, right? So here what I will do, I will get is future string, finally I will get the weather, right? So what it is saying is completable future. Okay, sorry. Okay, you don't have to. Okay, I got the point. You don't have to do this. Okay, so I just watched what it was giving me a warning. So whatever you combine and whatever you use, it will already return you as a completable future, right? This is whatever you will do, you will return here, it will already return you as a completable future. So it is returning something like this, right?
What it will return here is, let me tell you. Okay, it will return something like this: completable future dot complete और जो भी value है उसमें, right? So now whatever completable future we got, let's try to submit that. Submit. No, we can't submit that. We got the future, sorry. We only can submit futures, right? So this completable future is already evaluated to either of them, whatever. So whether dot get, whenever this result will get ready, this will run, right? Let's try to run it. So we are getting 40 Celsius, right? So let's suppose Delhi X, अगर मेरा लोकेशन Delhi X जो कि नहीं है, तो I will get 30 Celsius, right? So this is the chaining, like you want to chain F1 with F2, and then whatever you are getting, you are passing those in by function, right? This is by function which accepts by means two arguments, and it returns something. So something what it will return is completable future of string, right? So it is returning as completable future here, and yeah, that's it. Then I can, on future I can do get, right? I can use get. Cool. So another syntax, then a combine returns a completable future with transformed result. So this is what you have to bear in mind, that whenever you use then combine, whatever it will return, whatever it will return, using anything, whatever it will return, right? Whatever it will return, it will always wrap that return method in a completable future, what it is saying. There is another method, then accept both, returns a completable future void, indicating that it performs an action without returning a result. So if you will use then accept both here, right? Then accept both, it doesn't return anything, okay, and it doesn't return anything. It just do whatever you want to do. So here you are not returning anything. Inside of this you are just, let's suppose you go to the location, you go to the date, and then you want to send a email or send a post to this location and date. You can do that inside this. There is no need to return anything, right? You don't want to process anything whatever comes out of this method. So I can do processing inside, right? And this thing. So processing inside, what it does is, it will take F1, it will take F2, it will accept both of the futures. As soon as both of the futures complete their execution using any thread pool, the result of them will be passed this by function, and whatever you want to do inside, you can do inside. This is another method of chaining, then accept both. So here is written for your notes that then combine use a by function to transform the result and give it as completable future of result, right? Completable future के अंदर wrap करके देगा, and wraps in a completable future. But if you are using then accept both, it uses a by consumer to consume the result. So जो भी result आया है दो futures का, you can consume that and do whatever the heck you want to do, right? Okay, purpose क्या है? Then combine is for transforming and producing a new combined result, returns completable future. Then accept both is performing an action with combined result, returns nothing, right? Return type is written here, and then result handling. Okay, so we have then apply, right? We have then compose, then apply, then compose. Let's see what they do. Okay, then apply will accept a functional interface, okay, and that's it. So then apply, I think what it does is it returns u also, okay. So u is r, so it returns r, accept t, okay. So then apply, what it will do, it will accept something and it will return something, right? So what I can do here is completable future, it accepts string and it returns what it returns.
it returns completable future u. Then apply, and it accept something, right? What does it accept is then apply accepts string, right? String के क्या आ रहा है f1 से आ रहा है location, and let's suppose we return दिल्ली की जगह awesome location. Cool. So what I have done is then apply के अंदर if you will go, it takes an functional interface, so which is function itself. So functional interface takes t and u, right? And it returns completable future u, right? So if you'll go inside functional interface, it accepts one method, one lambda, which is accept t return r. So that's what I'm doing here. That's how functional interface work. You go inside, you check what is it accepting, what is it returning, then you pass that lambda exactly in that same structure. It is accepting string, it is returning what I want to return, it's also returning string, right? So function में it is accepting string, returning string. Go back. So function के अंदर whatever it is returning, it is returning string. So I will also return completable future string, right? Because whatever you want to return completable future, you want to get completable future of string, that function whatever this then apply will also accept a functional interface which will return you, right? Which will return you, right? So it's one to one mapping. अंदर अंदर जाते जाओ, you can map t u को t से, r को u से, all those things. But in a nutshell, in simple words, then apply takes a functional interface, accept string, return string, because I'm returning string. So then apply के अंदर whatever functional interface I'm using, whatever it returns completable future का wrapper on top of जो भी मैं return कर रहा हूँ. So I'm returning string, it will return completable future string, right? Now I can do future dot get and I can run this. Awesome Delhi, right? Cool. So then you have then compose. What it does is the returned completable future is flattened, avoiding nested completable future instances, used for chaining asynchronous stuff. You can ignore this, then compose. Cool. So now this is running future in parallel, like you have future 1, future 2, future 3, and then you can combine all of them future. Don't chain, don't tell कि f1 and f2 run हो जाए, then I will accept both, then I will combine both to get result. You're not chaining, you're just saying कि भाई f1 f2 f3 तीनों को complete करो, and once all of them are completed, so I am not doing future 1 dot get, future 2 dot get, future 3 dot get. I am doing combined future dot get. That is the thing. Now streams we have not covered, but this is how streams optionals will be used, but we'll come to that. So then another thing is कि if your future is throwing any exception, right? Let's suppose whatever future you are using here, instead of returning, it is throwing an exception, right? Not able to get result. ठीक है? Cool. So whenever some future is throwing an exception, while you are evaluating that exception, you can use f2 dot supply async wherever you have written. There only you can do handle, right? Handle. So handle में क्या होगा? S and T. Okay. S is nothing but a string, whatever the function will return. T is throwable, right? So it is like you tried something, you tried calling HTTP client, and that HTTP client thrown some exception, or your URL is even wrong, right? So in that case, what you will do, you will throw exception further, and when it is time to catch that exception, okay, when it is time to catch an exception, what you will do, this is a common syntax in JavaScript. Now people who are coming from JavaScript, they must be able to understand कि in Express.js, whenever you are getting anything in future, you will always write here request or response. I don't know, request response comes first, then request. This is the thing, bro. This is how it works under the hood. I know it's okay. In JavaScript you will not understand this, but fine. So you will see if t instance of runtime exception. So if it is an exception, you can do whatever the heck you want to do. You can type error, not able to do, or whatever. If you are able to get the things, then you can just do whatever you want to do here. I got the result plus s, right? And handle may what you are expected to do is you have to return a future, right? So okay, so what I'm doing here is I am making sure that whenever my f2 future is throwing any exception, I want to handle that exception. And if I'm not getting any exception, then just whatever the future was, I'm again returning that future. Dumb example, but that, yes. So now little bit more theory, that a completable future represents the eventual result of asynchronous operation. And I've already explained you that in literal terms it's not async. It's just an illusion that your application is getting a sense that your application thread is getting offloaded instantly, but your executor service is there, which is having some application threads, and that is responsible, right? Then the future has three possible states: pending state, completed successfully state, completed exceptionally state, right? Now there is one more concept where what wait forever means. When you call CompletableFuture.get, you are essentially saying block the current thread until the completable future transitions from pending state to either completed or exceptional state. So whenever you are doing CompletableFuture.get, right, whatever executor service that future might have used to complete its result, when I'm doing .get, I am expecting whatever the code was running, I am expecting the code to stop and wait until that completable future returns something. Why I know that it will not go in wait forever state is because it will always return me something. Either it will return me completed, or either it will return me completed exception, throw exception. If code is designed to produce the result has finished running successfully, but the completable future.complete result has not been called, then the completable future will remain in pending state. What it is saying is that here, if you have gone through that, here we are doing supply async and we are returning something. When you are returning something, it is nothing but it is completing the future with this value. But here when we made our own future, if you will not call complete here, you will submit a future, something, a runnable. There is no future at all to complete this function. It will sleep for 500 ms, it will return null. Now this completable future is not completed by any service, like executor service. No service has completed that. So whenever someone will call this, he will get future, completable future. Whenever he will call whatever .get, he will not get anything, always pending state. So that's why whenever you are using futures, always make sure you are completing them. So if no one calls either complete or complete exceptional, completable future remaining pending state, and therefore the thread calling get will block infinitely, because the condition it is waiting will never occur, right? Okay, I have explained executor service. Let's explain blocking versus non-blocking thread with executor service, right? I have already explained you how completable futures that we have discussed till now uses executor service to offload application threads का काम to executor service के fixed thread pool के ऊपर, right? Then there is OS and whatever, then these threads will go and get their work done. Why it is happening, I've already explained you, because in most of the cases, 90% of the cases, whenever we are making T1, T2, T3, T4 and using supply async or completable futures, we are doing nothing but using a service. And why we have to do that is because we are using HTTP file input stream and all for these threads, right? For these threads we are using them, and then if we are using them, then those are blocking in nature and we have to block them. So to block them, a hack is there. The hack is to offload application threads to a fixed thread pool, right? Because that is blocking in nature. Now there is one more thing on which Kafka, your databases are made in Java, which is Java NIO. Java NIO. This is a very, important thing. New input output APIs. So in Golang, if you are familiar with Golang, we have channels, we have streams. So in this case, this is actually truly async in nature. What will happen? You want to read some file. T1, it is not using file input stream, because file input stream, once it is opened, it is blocking in nature, right? And in that case, if you are using file input stream with future, it will use nothing but a async executor service, and that thread will be called. But if you are not using file input stream, if you are using channels, right, now what will happen? Your thread will be offloaded to OS. Now there is no intermediary thread pool. OS thread will read your file. It will read your file inside a buffer. Buffer is again nothing but an array, right, जो कि आपकी कंप्यूटर के अंदर ही है. It is not a hardware component, it is a software data structure. Whatever file content is read, it is being read into the buffer, right? And whatever the channel was opened for the thread, that will make sure that this channel, it's like a socket, this channel is responsible for getting the result. So T1 ne, as soon as it gets this work offload to OS will start reading in buffer, and then whatever content is in buffer will be passed to the channels. And as soon as my work is done, my event loop will tell ki by T1, now your work is done. This is truly async in nature, right? So reading from a file using Java NIO. Okay, now here we have buffers. You can see here we don't have any streams, we have buffers, right? So reading from a file using Java NIO involves utilizing classes such as file channel, which is byte buffer, to effectively or efficiently handle file operation. Java NIO, non-blocking IO. This is truly non-blocking in nature, provides a more efficient way to read and write files compared to traditional stream-based IO, especially for large files. There is a Java 1 billion row challenge also. What if I tell you that you have to read 1 billion rows from a file? This is the first method, you have to do it. There are other things like pages and all you have to use in memory, but this is one method. You are opening up a file, you are making a channel, then you are reading the file. For small files, you can use directly into memory, allowing them to read and write entirely in single operation. This is more, jargon. But what I was trying to tell you is that, let's suppose Java NIO file read versus stream based file read. Okay, so this is the point I wanted you to make a note about, that if you are reading a small file means कि भाई 5-6 lines है, but I am using a buffer of, let's suppose, 4096. It doesn't make sense, right? I am wasting my buffer. So in that case, directly read them. So traditional IO available since uses streams such as input stream. So performance, small files, traditional IO is good. Small files, large files के लिए use channels, right? So these are the points, right? Use non-blocking IO whenever you want to do memory mapped files, right? Whenever you want to handle large files. The homework here is that if I will keep on explaining each and every concept further and further, it will get more complex. So homework here is, after a point of time, we will explore Java NIO. But if you are curious, you should sure explore Java NIO, and then you should explore virtual threads, how exactly they are handling blocking IO in general, right? So that was it for concurrency session. It will become more clearer because there are a lot of concepts like wait, notify and all that we will not use in our projects, right? We'll use CompletableFutures and executor service most of the time, synchronized keyword most of the time. So all these things I have explained just because I want to make sure that you know things, right? So that you can go on internet and you can read blogs on your own, you can comprehend different articles on your own. Okay, so मिलते हैं अगले लाइव सेशन में कोहोर्ट के, तब तक के लिए बाय बाय.